Hey there. Welcome back to this quiet little corner of the universe. If you're curled up in bed, the lights dimmed, maybe a fan humming softly in the background, you're in exactly the right place. Tonight, we're going to let go of the day together and slip gently into something a little mind-bending, a little dreamy. Have you ever wondered what if the rules that hold our universe together suddenly changed, not just bent, but rewrote themselves? What if gravity got confused, or time ran backwards, or light forgot how fast to move? Don't worry, we'll take it slow, just like a bedtime story, but with a cosmic twist. If this kind of gentle curiosity keeps you company at night, feel free to tap that like button, maybe subscribe, or leave a quiet thought in the comments. Now, take a deep breath, let the world outside fade, and let's begin unraveling what might happen if the laws of physics didn't stay the same. The room is quiet, dim, and still. A soft current of air moves gently through the space, stirring nothing but comfort. The day has folded into night, and now, as the world slows, something deeper begins to surface, something quieter than thought, but older than memory. Beneath the softness of sheets and the familiar rhythm of breath, there is a hidden order working silently. Without permission or applause, it holds everything in place. It is not something that asks for attention, and yet it governs the way everything moves, rests, breaks, and returns. This is the balance, the invisible foundation of the physical world. It does not shimmer or shout, but it is everywhere, in every moment. Physics is not merely the subject of dusty textbooks or complex diagrams. It is the silent frame upon which reality is hung. It is in the way the floor holds weight, in how heat leaves a teacup, in why your heartbeat follows a rhythm. And yet behind all this stability lies something deeply delicate. The laws of physics are often described as constants, but the truth is they exist in a state of extraordinary precision, so fine, so impossibly exact, that even the smallest alteration could dissolve the entire structure of reality. The gravitational constant, for example, is not simply a number. It is a balance so perfect that if it were just slightly weaker or stronger, the universe would not be recognizable. Stars wouldn't form planets, wouldn't gather, and life would never have emerged. There is something unsettling and beautiful in that knowing how much had to align, how precisely things had to settle, just to allow one ordinary breath. Every force, every equation, every law that holds particles together and separates them from chaos. It all fits with the kind of elegance that seems accidental only until you look closely. Consider the speed of light. Not just a fast-moving thing, but a limit, a boundary. A constant that links time and space in a way so consistent it becomes the fabric of causality itself. Or the electromagnetic force which gently pulls atoms into molecules, allows neurons to fire, keeps stars burning in steady pulses. These aren't just forces, they are the quiet language the universe speaks to itself. And it speaks with such care. It's easy to go through an entire lifetime never feeling the presence of these laws because they do not intrude. They are faithful in their silence. But the moment they are questioned, even as a thought experiment, something stirs. A strange awareness, like realizing the floor beneath your feet, could vanish not out of fear, but out of curiosity. The physics that cradle the world do so with rules that seem so fundamental, and yet they're not set in stone. They're measured, tuned, balanced on the edge of what seems almost intentional. Even a small change in the fine structure constant, the number that controls how strongly particles interact with light, would completely alter chemistry. Nothing would bind. Structures would collapse. Stars might not ignite. The quiet magic of everyday life would unravel in silence. Still, these laws have held. For billions of years, through stellar births and cosmic deaths, they've kept their steady rhythm. They did not have to. There's no law saying the laws can't shift. In fact, many physicists have entertained the possibility that somewhere in the deep past or the far reaches of space, they might already be different. In other corners of the cosmos, if such places exist, the rules may hum in different tones. Perhaps there are realities where gravity is a whisper, or light bends in ways never seen here. Perhaps the universe we know is one chapter in a library full of unfamiliar physics. But in this chapter, in this quiet corner, everything lines up with startling grace. The energy in your body, the particles in your skin, the warmth of your surroundings, all of it held by rules so consistent they seem eternal. Yet they are not. They are conditional. They work because they work here. And that is a fragile miracle. To rest under the spell of such balance is to realize how rare and generous this existence is. No dramatics, no noise, just a quiet unfolding of logic and law unfolding again and again from the moment of the Big Bang to the quiet moment you are now within. The more these laws are studied, the more uncanny their perfection appears. There are 20 or so constants in the standard model of physics, and every one of them is necessary for the kind of universe we live in. Change. Just one of them even slightly, and the consequences ripple through everything. But they don't change. At least not yet. They endure. They support the flicker of stars and the warmth of skin, the curve of an orbit, and the bonds in DNA. And through all of this, the math, the mystery, the unlikeliness of it all, there is a strange comfort. The world is not simple, but it is coherent. It makes sense. It holds. And that holding is what allows us to feel safe, to feel gravity beneath us, and time moving forward to feel warmth as heat moves from place to place. These are not illusions. They are consequences of deeply rooted laws. But what if that balance is not permanent? What if it is only temporary or conditional or local? That is where this journey begins, not in panic or chaos, but in curiosity. What if gravity drifted? What if light's speed faltered? What if entropy reversed or friction vanished? What would that mean for the world, for life, for consciousness? These are not just questions for scientists. They are questions for everyone who has ever looked at the stars and felt something more than distance. The laws of physics are not cold. They are not indifferent. They are the shape of this reality. And if they were to change even subtly, the ripples would move through everything from galaxies to the smallest thoughts. Tonight begins with honoring that balance, with noticing what usually goes unnoticed, with holding just for a while the weight of everything staying the same. And tomorrow, perhaps, we'll begin to explore what happens when it doesn't. Gravity does not ask for attention. It does not shine or sing or move in dramatic sweeps. It simply stays, quietly, dependably. It holds the oceans to the earth, the moon to its orbit, the mountains to their roots. It cradles everything from raindrops to galaxies, from the rhythm of a pendulum to the architecture of the cosmos. And in that silence, it feels eternal, so deeply woven into every experience that the idea of its change almost escapes thought. But gravity, like all physical forces, is defined by a constant, a number so small, so delicate that a change in even 1 part per billion would echo through everything we know. A universe where gravity is just slightly weaker would not be a dramatic spectacle of floating people and levitating chairs. It would be a slow unraveling. Buildings would no longer support their weight in the same way. The structure of bones would bend under pressures they were never built for. Rivers would flow differently. Mountains would crumble more easily. Even the blood in your body, which moves with the assistance of gravitational pull, would find new paths or none at all. On a cosmic scale, the consequences become more profound. A weaker gravitational force means less cohesion in matter. Stars, which are born from the gravitational collapse of dust and gas, would struggle to ignite. Without the pressure to spark nuclear fusion, many stars might never shine. The night sky would dim, and even those stars that did form would burn differently, faster, shorter, less stable. Solar systems would wobble, orbits would stretch and snap, planets might not stay where they are. Earth could drift gently but irreversibly away from the sun. Seasons would change in unexpected ways, temperature gradients would warp, life would be pushed into patterns of adaptation it might not survive. But even more unsettling is the thought of what happens when gravity becomes stronger. Just slightly. Not enough to collapse the Earth into a singularity, but enough to add weight to every step, every breath. Trees would struggle to grow tall, wings would falter. The sky, once open and spacious, would become unreachable. Human bodies built for balance under a specific gravitational load would tire faster, bend sooner, and break more easily. Over time, evolution might adjust shorter limbs, sturdier frames, slower movement. But the transition would be neither graceful nor kind, and again, on the scale of stars and galaxies, the change would be devastating. Stars would collapse more quickly, burning through their fuel with relentless hunger. Supernovae would become more frequent, scattering heavy elements more violently, yet perhaps too quickly for new planetary systems to stabilize. Black holes would form more easily, devouring their surroundings with even greater force. The large-scale structure of the universe, the filaments and voids and clusters that stretch across billions of light years, would become denser, tighter, more volatile. Galaxies might collide more often. Chaos would rise where grace once ruled. But the most haunting part of it all is that none of this needs to be a large change. Gravity is so finely tuned that a shift too small to measure by hand could still reshape everything. If an apple no longer falls with the same certainty, the chain of consequences is infinite. The tree, the soil, the planet, the orbit, the star, the galaxy, all of it subtly influenced by that one deviation. And yet, for most of human history, gravity went unnoticed. It wasn't named until relatively recently, and even now its true nature remains elusive. We know what it does, but not entirely why it does it. It bends space-time, yes. It curves the path of light, yes. But what is it really? A particle A wave, a property of space itself, no one knows for sure. And in that not knowing there is both mystery and risk. Because if we do not fully understand gravity, how can we be certain it cannot change? Some theories suggest that in the early universe, gravity may have behaved differently. Stronger or weaker depending on the temperature, the density, or some hidden variable we've yet to uncover. There are even models where gravity is not a fundamental force at all, but an emergent property, something that arises from deeper principles still buried beneath our current understanding. If that's true, then gravity is not guaranteed. It is not written into the fabric of reality. It is woven perhaps loosely, and could shift if the conditions that support it were to change. And if that were to happen, the consequences would not arrive like thunder. They would whisper in slowly. The days would feel slightly longer or shorter. The weight of a familiar object might seem off. Bridges might sag in ways that don't quite make sense. The moon's pull on the tides might ebb or surge unpredictably. It would begin subtly, almost imperceptibly, but eventually the world would no longer behave the way we remember. And yet tonight, none of that has happened. Gravity still holds, apples still fall, stars still burn, and that steadiness is something to feel deeply, even quietly thankful for. The world beneath you remains solid. Your breath moves with a rhythm that hasn't changed. The sky above still wraps the planet in orbit, and tomorrow will arrive on time. But knowing how easily this could shift doesn't bring fear, it brings reverence. The law of gravity is not just a number, it is a lullaby of the universe softly pressing things into place, not by force, but by patience. And if it ever changes, the change will be a story written in the tilt of mountains, the rhythm of oceans, and the way we learn once again to stand. For now, the balance remains, and in that balance, sleep comes easier. The earth still spins, the stars still rise, the quiet law of gravity still sings its invisible song, holding you here in this moment, in this night, in this breath. Energy is everywhere. It hums through wires, radiates from stars, moves blood through bodies, and heat through tea. It doesn't appear from nowhere, and it doesn't simply vanish. It flows, it transforms, it dissipates. These behaviors, this quiet discipline of how energy behaves, are captured in a set of rules so familiar yet so foundational, they often go unnoticed. The laws of thermodynamics. They are not loud laws. They do not crash or flash or pull, but they shape every breath, every fire, every life. The first law, simple and steadfast energy, cannot be created or destroyed. It only changes form. The warmth in your hands came from food, which came from the sun, which came from fusion, which came from gravity, compressing hydrogen in a long-forgotten cradle of dust. Nothing was invented. Everything was transferred. The second law, more mysterious, more solemn in every process, some energy becomes less useful. Heat slips away, spreads out, diffuses. Systems move toward disorder. This is entropy, not chaos, but a slow smoothing out of energy, a gentle fade. And the third law, colder still, as a system approaches absolute zero. Entropy approaches a minimum. Order solidifies, motion quiets. Nothing moves, and even time seems to pause. These laws do not ask to be noticed. They simply are. They underpin the way heat moves from your skin to the air, the way ice melts, the way stars burn out. They are the reason perpetual motion is a myth, and why no machine is ever perfectly efficient. They keep the world honest. But what if they didn't? What if these laws, so firm, so absolute, began to falter? What if energy could be created, or if entropy ran backward? What if heat flowed from cold to hot, and the arrow of time bent in strange, impossible loops? The consequences would not be fireworks or spectacle. They would be quiet unravelings. Engines might run without fuel. Ice might freeze in warm hands. Rooms might heat themselves endlessly. The problem would not be that things stopped working, but that they worked too well, without loss, without waste, without end. A world without thermodynamic laws is a world without limitation. At first glance, that seems beautiful. No decay. No loss, a perfect tireless system. But there is a hidden cost in perfection. Without the second law, time loses direction. Entropy is not just about disorder, it is about memory. It is what tells the universe what came before and what comes next. Remove entropy and moments blur. Events repeat. Causality stutters. A cup that once cooled might warm again without reason. A candle that burned out might reignite. Death itself might become uncertain. Thermodynamics does more than guide machines. It anchors time itself. And without it, life would lose the very fabric that makes experience coherent. On a biological level, cells rely on gradients, differences in energy to do work. Muscles contract, neurons fire. Enzymes catalyze all through processes that depend on energy flowing from high to low, from ordered to disordered states. Without that flow, the body becomes still, not from exhaustion, but from confusion. Energy would swirl in place, neither decaying nor building useless in its perfection. And on a cosmic scale, stars would never die. Galaxies might glow eternally. The night sky would not dim, but it would become frozen, unchanging, unwavering. That might seem eternal, but it would not be alive. Because life, as strange as it sounds, needs waste. It needs imbalance. It needs the gentle slope of entropy to move forward. The warmth of the sun becomes food, becomes motion, becomes thought, becomes memory. Each step loses a little energy. And in that loss, something is gained: movement, meaning momentum. Even the rhythm of sleep follows thermodynamic cycles, cooling, slowing, releasing. The warmth of waking, the drift of dreaming, the deep restoration of rest. All of it is an orchestra conducted by the laws of energy flow. If those laws disappeared, sleep would become shallow or endless. Wakefulness would blur. Time in the mind might drift or split. The brain, which consumes so much energy just to be, would lose its grip on now, on before, on next. The world would become a place where processes neither begin nor end. And in that stillness, everything would fade. But even now, tonight, those laws hold. The warmth in your chest moves slowly outward into the fabric around you, into the air. The energy in your body is settling, cooling, restoring. Nothing is wasted, just transformed. Every breath is a whisper of thermodynamics, keeping time, guiding rest, supporting life. These laws do not need your attention, but they deserve your respect, because they are the quiet architects of change, the protectors of balance, and if they ever stopped holding, the world would not explode, it would stop evolving. And without evolution, there is no story, and without story, there is no life. So let that thought settle into you gently. Let it hold your breath, your body, your quiet mind. The laws of thermodynamics are still here, energy still flows. Entropy still gives direction. Time still moves forward. And in that forward motion, rest is found. Order is a delicate thing. It takes energy to create, to maintain, to protect. A room cleaned, a memory formed, a structure built. All are acts of organizing the world against its natural drift toward disorder. That drift, slow and inevitable, is known as entropy. Not chaos, not destruction, but the gradual spread of energy, the gentle fading of difference. Over time, things even out. Heat disperses, structures wear down, life slows. Entropy is not the villain. It is the rhythm by which time breathes. It gives direction to events. It tells the universe what's past, what's possible, what's to come. And yet, deep in the language of physics, a quiet question persists. What if entropy could reverse? What if instead of things falling apart, they came together? Not by design or force, but naturally, inevitably, like a film running backward but not visibly so. A universe where disorder does not grow, but contracts. Where systems grow more organized with time. Where broken things restore themselves. In such a world, a shattered glass would reform silently on the floor. Ashes would rise and reassemble into flame. Structures would become stronger, not weaker, the longer they existed. But it would not stop there. Memory would work differently. The brain, which stores information through complex, energy-intensive encoding, would begin to recover forgotten knowledge. Not by revisiting the past, but because the very medium of memory, its chemical and electrical trails, would grow clearer with time. Thoughts would crystallize instead of blur. Aging might reverse not through biological miracles, but because molecules, cells, and tissues would naturally return to their more ordered states. But what does that mean for life? At first it sounds hopeful. Restored memory, rebuilt form, regeneration. But beneath that hope lies something unsettling. In our universe, life thrives in the tension between order and entropy. We live because energy flows from higher to lower, from sun to plant, from food to cell. That flow creates the spark of metabolism, the pulse of motion. In a universe where entropy decreases, that tension vanishes. Systems become more ordered not by consuming energy, but passively. Plants might not need sunlight. Cells might not need food. Growth would become a return, not an expansion. Learning might become remembering. Creativity might become reconstruction. The arrow of time would still point forward, but forward would no longer mean unfolding complexity. It would mean refinement, convergence, compression. The universe would not expand into possibilities, but contract toward perfection. On a cosmic scale, galaxies might spiral into tighter, more defined forms. Stars might burn cleaner, longer. Dust would gather itself into patterns without pressure or pull. The sky would look sharper, colder, less scattered. But beauty does not always thrive in perfection. It thrives in surprise, in the unexpected, in the entropy that allows difference, movement, evolution. Without entropy, life might not evolve. Mutations would be corrected, deviations would smooth out, everything would regress, not into nothingness, but into symmetry. And symmetry, while beautiful, is also static. In this universe, diversity would decline. Variation would be rare. Every system would tend toward an ideal form, stripping away the unexpected. Rain might fall in perfect patterns. Trees might grow in identical shapes. Music, if it existed, would repeat the same harmonic sequence endlessly, not because of boredom, but because the physics would insist on it. On a personal level, such a world would feel quiet, controlled, perhaps comforting. But it would lack the messiness that gives life its color, the chaos of inspiration, the accidents that become discovery, the decay that leads to transformation. Without entropy, fire would never die, but neither would ash give way to soil. Nothing would be lost, but nothing would be born. Emotion, too, may behave differently. In our reality, emotion is tied to memory, to experience, to change. Love deepens over time because of shared entropy, because things break, and we hold them anyway. In a world that becomes more ordered, pain may vanish, but so might growth. Relationships might not evolve because nothing ever changes enough to demand it. Suffering may soften, but joy may flatten too. And the rhythms of day and night, heat and cold, age and youth, might fade into a long, slow drift toward sameness. Entropy gives time its texture. Without it, time becomes smooth, almost too smooth. And in that smoothness, identity blurs. Perhaps even thought becomes still. For all our longing for order, we are creatures of tension. We rise because we fall. We reach because things move away. Even rest true. Rest only feels whole after motion. That balance between chaos and structure is not a flaw, it is a gift. So if entropy ever reversed, if the laws turned in on themselves, we would not simply gain order, we might lose the freedom that disorder brings. And yet tonight, entropy still flows forward, heat still fades, energy still spreads, and in that spreading possibility remains alive. Sleep comes not from stillness, but from soft transitions. From the warmth leaving the skin, the thoughts diffusing the body, settling. The second law of thermodynamics continues to sing quietly in every corner of the world, and as it does, the future stays open, not perfect, not polished, but alive. There's something comforting in consistency. The idea that once something moves, it keeps moving unless something stops it. That's inertia, a quiet promise made by every object, from the spinning of planets to the swing of a child's leg. It doesn't ask for energy or command attention. It simply continues. That continuation, so effortless, so deeply rooted in the laws of motion, is the backbone of stability. When a ball rolls across the floor, it's not fighting for motion, it's trying to keep it. When Earth circles the sun year after year, it's inertia that carries the momentum. It is the law that lets motion persist undisturbed unless something nudges it. But what if that changed? What if motion didn't stay in motion? What if the act of moving required constant reinforcement, as if the universe began to resist even the simplest path? In that world, a thrown stone would fall sooner, as if tired. A car once accelerating would slow, not because of friction, but because motion itself decayed. Everything would hesitate. Movement would become a task, not a tendency. The laws that once allowed simplicity in motion would now demand effort, attention, adjustment. Every action would feel heavier, not in mass, but in continuity. For the human body, it would be subtle at first. The walk to the kitchen might take more steps than expected. The stretch of an arm might feel incomplete unless repeated. Muscles would learn new rhythms, but they would also tire more quickly. Coordination would falter. Sports would become strangely still. A thrown ball would arc, then stall. A runner's stride would lose glide. The world would slow not because of resistance, but because inertia had been silenced. On larger scales, the consequences grow stranger. Planets might begin to drift out of orbit, not flung away, but quietly falling inward or outward, unable to sustain the perfect balance of motion and pull. The moon's path around Earth might become unstable. Satellites no longer coasting would require constant correction. Energy costs would rise everywhere, not because of distance, but because nothing could stay the same for long without being pushed. In transportation, the change would be profound. Airplanes would need more thrust. Trains would slow between every pole. Even rivers might change their behavior as the water's flow would weaken without inertia to carry it beyond gravity's pull. The air itself might feel thicker not by density, but by demand. Every breeze, every swirl of wind would require constant cause. Motion would not be preserved, it would be rented temporarily, always needing payment. And in the realm of the mind, something more delicate might stir. Thoughts too move. They follow pathways, some automatic, some intentional. Memories are not just stored, they're traveled. Associations form from movement within the brain. And if motion at its core becomes unstable, cognition might feel different. Trains of thought might stall. Focus might require more energy. The act of completing a sentence could become less fluid. Emotion carried through motion in expression and posture might become subdued, and time so often measured by consistent motion would feel different. Not broken, but irregular. The tick of a clock once dependable would need reinforcement. Pendulums would falter. Timekeeping would need constant recalibration. The Earth's rotation, once rhythmic, might shift. Days might lengthen unevenly. Sleep cycles could unravel. And yet for all these changes, the world would not fall apart. It would adapt, slowly, carefully. But life would move in fits and starts. Less like a dance, more like a careful walk on shifting ground. Systems would need constant input. Motion would become a currency, rare and valuable. And the quiet ease of coasting, of drifting, of simply continuing would be gone. But tonight, inertia still holds. Movement remains a gift that renews itself until interrupted. Your breath continues without command. The blood in your veins flows unasked. Earth still turns gently, steadily, carrying us forward. Trains of thought still carry dreams from one idea to the next. The wind still moves in graceful patterns, needing no push but its own beginning. Inertia makes this possible. It gives rest its meaning because motion can pause and resume. It gives time its feel because change can continue. And it gives sleep its softness because stillness is not forced, only welcomed. So in this moment, beneath the still sky and the slow hum of night motion persists without resistance. A breath in, a breath out, no correction needed. Inertia carries you gently, like a slow current in a warm sea. And in that quiet momentum, rest becomes inevitable. Some truths are so deeply woven into daily life that they stop being noticed. One of them is cause and effect. The cup falls because the hand slips. The rain pours because the clouds grew heavy. The light turns green and the car moves. These sequences do not feel remarkable. They feel expected, predictable, even comforting. It is not just the rhythm of nature, but the logic that makes understanding possible. Without cause and effect, the world would still exist, but it would no longer make sense. Events would still happen, but they would have no anchor, no direction, no reason. The warmth in a room might increase without a heater. A tree might fall while the wind is still. A word might echo before it is spoken. This is more than a theoretical disturbance. It is a dismantling of the one principle that links all things through time. Cause and effect give memory its structure, intention its power, and science its method. Without it, action is a coin toss, meaning becomes blur, and time becomes unstrung. At the most basic level, cause and effect are what allow systems to evolve. They tell particles how to interact, tell chemicals when to react, tell signals when to fire. If that order is removed, reactions might not complete. Information might not transmit. Outcomes might drift from origins with no trace of connection. In such a reality, the body would struggle. Reflexes depend on response. The mind relies on patterns. Habits, learning, decision-making, all built on the assumption that action leads to consequence. If that chain breaks, behavior becomes trial and error with no feedback. Pain might come before touch. Hunger might follow eating. Conversations might reverse themselves mid-thought. Even sleep, which follows cycles, would lose its pattern. Dreams might invade before the eyes close. Wakefulness might come without reason. The rhythm of night and day would no longer feel like a flow, but a flicker. Time's arrow, which once guided all things forward, would lose direction. On the scale of nature, the change would be even more profound. The seed would not always grow after planting. The sun might rise without cause or fail to rise despite every condition. Seasons would lose meaning. Migration patterns would collapse. Ecosystems would falter not from external threat, but from the erosion of predictability. In physics, this principle is called causality. It's not just a philosophical idea, it's a framework that determines what kinds of events are allowed in space-time. It protects the order of things. It ensures that effects are constrained by what's possible, by what has already occurred. Remove causality in space-time no longer has a story to tell. It becomes a canvas where brushstrokes appear randomly untied to any hand. The idea of progress itself vanishes. For technology, this collapse would be devastating. Code would become unreliable. Circuits would misfire. Calculations would drift without warning. A machine might turn itself off before receiving the command. Communication systems would become noise. Prediction models, weather markets, health would lose all coherence. But deeper still, human consciousness would struggle to exist. Thought flows from trigger to reaction, from memory to association, from question to answer. A mind without causality is not just confused, it is fractured. A person could laugh before hearing the joke, feel regret before making the choice, experience longing without knowing for what. This would not feel like madness, it would feel like fog, like standing on a shore where every wave arrives from a different sea. And yet, even here tonight, that fog has not come. Cause still leads to effect. The sound of the wind is still born from its movement. The quiet of the room is still shaped by the absence of noise. Your breath still draws because the lungs ask for it. Sleep still follows the fading of stimulation. That is the soft promise of causality it holds even when unnoticed. It links moments into a thread. It gives time its depth. It gives memory its path. It gives life the ability to look backward and forward and know the two are different. So, while it is possible in theory that cause and effect could break for now, they remain our most faithful companion. They make this quiet moment possible, not as a random flicker, but as a product of all the moments before. The thoughts leading up to this rest, the choices that brought this stillness, the softness that follows effort, cause-effect, day-night, wake-sleep, and in that gentle chain, comfort remains. There is a strangeness at the heart of everything, a quiet, restless uncertainty that lies not in the stars or the galaxies, but in the smallest building blocks of reality. Beneath atoms, beneath protons and neutrons, there is a world of particles so delicate and elusive that they seem to flicker between states, choosing and unchoosing their position, their momentum, their very identity. This is the quantum realm where particles are not things but possibilities, where matter does not commit to one state until observed, where cause and effect bend into probabilities. In this domain, the world is not made of solid certainty, but of soft chances measured by something we call the wave function, a mathematical whisper that tells us the likelihood of where something might be not where it is. The quantum rules that govern this world are not like the laws of gravity or motion. They are less rigid, more slippery. They speak in the language of chance. A particle might go left or right, pass through one slit or another, decay now or later. And every time the outcome is not determined until it happens. This is not a flaw. It is how everything, including you, exists. At the quantum level, nothing is guaranteed, but the probabilities are stable. They follow precise patterns. They behave statistically, even if individually unpredictable. That fragile consistency makes reality reliable. But what if it didn't? What if the probabilities stopped behaving? What if the wave functions? No longer resolved into expected distributions? What if outcomes no longer aligned with even the loosest patterns? In that world, the randomness would no longer average out. The strange would no longer be rare. Quantum events would become lawless. The foundation beneath everything would shift not loudly, but constantly. In such a universe, atoms might not form properly. The binding energies of electrons could vary from moment to moment. Chemistry would become erratic. Reactions might proceed or not, regardless of conditions. The structure of molecules would become unstable, shifting configurations in real time. DNA could no longer replicate predictably. Proteins might fold incorrectly or too many ways at once. Life built on the reliability of probabilistic interactions would begin to fragment, not instantly, but inevitably. Over time, the body's machinery would become unreliable. Cells would behave oddly, then collapse. Metabolism would drift, repair mechanisms would fail, memory, mood, movement, all would become suspect. And in the wider world, nothing would stay familiar. Light, whose behavior depends on quantum fields, might behave erratically. Some photons would never arrive, others would multiply unpredictably. Shadows would flicker in places without cause. Electronics would fail first transistors, and semiconductors depend entirely on quantum predictability. Computers would become irrational. Code would yield nonsense. Storage devices would corrupt not from wear, but from the laws that once governed their function, no longer obeying their own rules. Even clocks which rely on atomic transitions would falter. Timekeeping would dissolve, synchronization across the planet would blur. GPS systems would wander, navigation would become guesswork. But the most disorienting changes would be subtle. A memory would vanish while being recalled. A name might be different each time it's spoken. Matter could shift states without energy. Heat could condense into cold. Glass could melt from stability. Not dramatically, but inconsistently. The world would no longer behave in a way that could be learned or remembered. Prediction would die. Not because things are unknowable, but because even the chances would stop making sense. Some particles might disappear without decaying. Others might blink in with no history. The sense of continuity, the quiet hum of knowing that what has worked before will work again, would evaporate. Language would degrade. Logic would tire. Consciousness might become fractured, not from trauma, but from an inability to relate one moment to the next. And yet, in the absence of probability, something else might arise, a sense of pure presence. In a world where no future can be guessed, all that remains is now. But that now would feel thin, fragile, unanchored, like standing on mist. There would be no rhythm, no expectation, only surprise, not wonder, just strangeness. Even emotion could become slippery. The chemicals that shape mood are governed by probabilistic rules. If those rules fractured, joy might short-circuit into melancholy without reason, or never appear at all. Decision-making, too, would wither. There is no choice without expectation. And without a reliable sense of consequence, intention dissolves. You would act, perhaps, but not for reasons, just for motion. And yet, this is not our world, at least not tonight. Quantum rules still hum in place. Particles still dance within their boundaries. Probabilities still hold with enough reliability to build stars, planets, consciousness, and thought. The uncertainty remains, but it is framed. It is patterned. It is woven into a structure that gives rise to meaning. Light still behaves. Matter still coalesces. Chemistry still dances in warm, pulsing rhythms. Your body still operates. Your thoughts still align. The laws may be strange, but they are not broken. The quiet contract of probability is still honored, and in that honor, rest becomes possible. The wave function collapses gently into outcomes that allow sleep to arrive softly, carried not by certainty, but by a trust that even chance can be kind. The universe, with all its strange subatomic trembling, still folds itself into forms you can hold, into warmth, into breath, into quiet, and in that quiet, this moment, this gentle unfolding, now makes perfect sense. There is a force that touches everything. It doesn't pull like gravity, nor does it explode like the strong nuclear bond. It hums instead, invisible, but constant in every wire, every atom, every breath of warmth. It is the reason your heart beats, your voice travels, your screen glows. This force is electromagnetism, the silent thread that binds particles into atoms, atoms into molecules, and molecules into life. It gives shape to the world not by pressing, but by holding. Every spark, every light, every nerve signal is a ripple in its field, and yet we rarely notice it. Its presence is quiet, its reliability assumed. But if it were to vanish, the silence would not be peaceful, it would be absolute. Without electromagnetism, electrons would no longer orbit nuclei. Atoms would collapse, chemistry would cease, the matter would lose structure. There would be no solids, no liquids, no gases, only a wash of fundamental particles with nothing to bind them. There would be no light, because light is an electromagnetic wave. The universe would darken instantly, not gradually, not at dusk. The glow of stars, the shimmer of fire, the softness of screens all gone in the same breath. Photosynthesis would stop, vision would become meaningless. But these are surface losses. Deeper, more quietly, the body would dissolve. Nerves rely on electrical signals, a delicate choreography of charged particles flowing across membranes. Muscles, including the heart, are triggered by these signals. The brain in its entirety is a pattern of electromagnetic activity. Without the field, the pattern vanishes. Thought vanishes. Not in pain, not in drama, just in stillness. And beyond the body, everything familiar would fall apart. Metals would stop conducting, magnetism would vanish, compass needles would still. Wireless signals, radio waves, infrared warmth, none of it could exist. The global web of technology would fall silent, not fail, disappear. There would be no spark to ignite fuel, no current to light a room, no pulse in the circuits that drive memory communication or computation. The Earth's magnetic field, which shields us from solar wind and radiation, would collapse. Particles from the sun would strike the surface unimpeded. And yet there would be no auroras to mark the event, because there would be no light. The planet would not burn. It would simply begin to break. Atmospheres held loosely by magnetic interactions would drift. The air itself, with its charged particles and electromagnetic cohesion, would thin, then bleed away. Water molecules would separate. Hydrogen and oxygen, no longer bound, would scatter. Clouds would vanish. Rain would end. Life in all its forms would not die in agony. It would dissolve into silence. But the silence would not come instantly. At first, there might be a flicker, a strange dimming. Devices would stop responding. Signals would fail. Then a deeper hush as the warmth fades, not just from engines, but from touch. The heat from your skin, once radiating into the room, would no longer move outward. Infrared radiation, an electromagnetic wave, would no longer exist. Temperature would stop being shared. Warmth would become trapped, then lost. You would feel neither heat nor cold, just stillness. Even memory, if it could persist, would find nothing to connect to, because memory itself is electric small pulses across fragile pathways, preserved by the electromagnetic scaffolding of molecules. Without the field, even the past is erased. But all of this is a shadow, a hypothetical drift into nothingness, because tonight electromagnetism still hums. The photons from stars that left centuries ago still reach your eyes. The tiny electrical fields in your brain still ripple in steady waves. The charge across your neurons still pulses gently, telling muscles when to move, organs when to work, thoughts when to arrive. Every conversation, every connection, every moment of recognition made possible by this quiet force. And though it is vast, stretching across galaxies, it is also intimate. It is in the crackle of a wool sweater, the spark of a touch, the soft glow of a candle. It is warmth, it is vision, it is thought, and its presence is not just necessary, it is generous. It gives without demand, it sustains without praise. So in this moment, in this breath, feel what it allows, the rhythm of your heartbeat, the warmth in your chest, the soft quiet of a room held in light. Electromagnetism does not ask for thanks, but perhaps in this stillness it receives it anyway. As your thoughts soften, as your body quiets, as the night holds you in its gentle field, remember light still travels. Signals still connect. The force that binds atoms still holds. And because of that, so do you. There is a number small and strange that hides at the heart of everything. It doesn't stand out like the speed of light or the pull of gravity. It's not printed in textbooks with flashing labels, and yet without it, there would be no stars, no atoms, no color, no chemistry. It is called the fine structure constant, known as alpha, a dimensionless value roughly 1 over 137, quietly controlling how light interacts with matter, how electrons cling to protons, how atoms hold shape, how the universe paints itself in form and function. This number is not just important, it is essential. If it were even slightly different, atoms would fall apart or never form. Electrons might not orbit. Molecules would never bind. Chemistry as we know it would cease, not in violence, but in absence. And yet this number is not imposed by anything external. It simply is. No one knows why, no one knows if it could be different. But if it changed, if the fine structure constant drifted even slightly, the entire periodic table would unravel. The delicate balance between electric charge and quantum motion would shift. Electrons might spiral into nuclei, collapsing atoms into instability. Or they might float too loosely, unable to bind. The structure of elements would warp. Hydrogen might become inert, carbon might not form, oxygen might not exist. The building blocks of life would be erased not by force, but by misalignment. And it would happen quietly. The rules that allow water to flow, DNA to spiral proteins, to fold those rules would change. Enzymes would fail, reactions would stall or ignite unexpectedly. Acid and base would lose meaning. The subtle choreography of bonds and angles would dissolve. Life would not burn out. It would fade. Its pattern lost. Even the stars would feel it. Fusion in stellar cores depends on this constant. If alpha were slightly stronger, stars would burn too hot, collapsing before planets could form. If weaker, they might never ignite. There would be no light, no warmth, no planets orbiting suns. The sky would be dark, not because the stars died, but because they were never born. On Earth, materials would shift in strange ways. Metals might crumble, gases might solidify, salt might lose its taste, color itself would change. The way light is absorbed and emitted by atoms is controlled by this constant. The blue of the sky, the green of leaves, the red of blood, all would alter. Some colors might vanish, others might appear alien, uncanny, without correspondence to anything we know. And in the mind, something subtler would stir. The brain's chemistry is precise. Neurotransmitters dock at receptors with exact shapes determined by atomic structure. If that structure drifted, thoughts might blur. Emotions might untether. Memory could fray. Language could lose its edge. Not all at once, but slowly, as the physical basis of thought becomes unsure. Culture, art, science, they all depend on a stable chemistry. Without it, knowledge cannot accumulate, music cannot resonate, identity cannot root. Civilization would not collapse dramatically. It would dissolve in ambiguity. But none of that is happening tonight. Alpha still holds, electrons still orbit with gentle precision, molecules still bond, water still flows, breath still carries oxygen to blood. The number one part in 137 still governs the song of matter. And though we do not feel it, we live because of it. The softness of fabric, the taste of fruit, the warmth of skin, each a consequence of this silent constant. It shapes the world without effort. It defines complexity without seeking attention. And in its quiet, the world becomes knowable, balanced, intelligible. So as night deepens and the body unwinds, let that number hold you too, not as a fact to memorize, but as a rhythm to trust. The fine structure constant is still in place. The atoms still sing in harmony. Chemistry still dances with light. And in that stability, sleep finds its way slow, soft, silent through the pathways that have not changed. Deep within every atom beneath the shell of electrons and beyond the electromagnetic pull of orbitals, there is a quiet tension holding everything together. It is not loud. It does not pulse like a heartbeat or shine like a flame. It is silent, binding, final. It is the strong nuclear force, the most powerful of nature's four fundamental interactions. And yet, despite its name, it acts only across the tiniest of distances. It binds protons and neutrons together within the nucleus, holding matter in place against the fierce repulsion of like charges, keeping atoms from tearing themselves apart. Without it, there would be no structure, no atoms, no matter. The stars would never have ignited the earth, never formed, and the fabric of existence would drift into meaningless dust. This force is so strong that it overcomes the electromagnetic repulsion between protons in an atomic nucleus. It acts with a purpose that feels absolute. But what if that force began to weaken, not vanish completely, just diminish quietly, subtly enough that it could no longer hold particles together in the same tight embrace? The first signs would come at the smallest scale. Nuclei that were once stable would begin to decay. Elements that had stood unchanging for billions of years would shift. Carbon, oxygen, iron, all the essentials of life would fall apart molecule by molecule. The periodic table would fracture, not from heat or time, but from the betrayal of cohesion. The hydrogen in water, the calcium in bones, the iron in blood, all would become unstable. Fusion in stars would falter. Without the strong force at full strength, the balance between energy and gravity would shift. Stars would begin to dim. Those already burning would struggle to sustain the reaction in their cores. Their lifespans would shorten. Some might never ignite. Light itself would retreat. The night sky would lose its stars, not with a bang, but with a long, slow fading. The warmth that has always arrived from the heavens would stop. Planets would cool. Solar winds would weaken, and yet more quietly still, the earth would begin to unravel. Rocks would weaken at the atomic level. Metals would corrode not with time, but with structural collapse. Buildings would not crumble from storms or earthquakes, but from within. Materials would lose their definition. Mass would drift apart into smaller and smaller pieces, unable to maintain form. The human body, held together by trillions of stable nuclei, would soften, break down not from disease or decay, but because the architecture itself could no longer stand. DNA would degrade, cells would lose their identity, the delicate chain of life's code would unspool. Thought, sensation, memory, all chemical, all atomic, would fracture. It would not be painful, it would not even be frightening. It would feel like losing the ability to hold shape, like trying to grasp water that slips away endlessly. Time would remain, gravity would still pull, but the pieces being pulled would no longer connect. The fundamental glue that makes form possible would be gone. And beyond biology, history would fade, not because we forget, but because the tools we use to remember would vanish. Books would crumble, devices would corrode, digital storage would dissolve, language itself passed from mouth to ear, depends on the vibration of molecules. If the atoms fall apart, sound cannot carry. Communication would grow silent, culture would dissipate like mist. Civilization would not fall, it would disperse. But none of this is happening, not tonight. The strong nuclear force still holds. Nuclei still resist the push of protons against each other. Stars still burn because hydrogen can fuse. Elements still persist because their cores are secure. The iron in your blood still carries oxygen. The phosphorus in your bones still holds. The atoms that make your thoughts possible still remain whole, faithful in their internal gravity. We do not feel this force. We cannot touch it or see it, but we live because of it. The structure of matter is a gift of this invisible strength, and its silence is not emptiness. It is assurance. It says you will hold, you will persist, you will remain. So as the night wraps gently around you, and the breath slows, and the warmth of the bed becomes the whole horizon, know that the world beneath you has not weakened. The walls, the floor, the ground, the earth, everything still holds because the smallest pieces still hold. And as long as that holds, you can rest. There is a force so faint, so subtle, that even in a world built entirely upon its effects, it almost never draws attention. It does not hold the earth in orbit. It does not bind atoms together. It does not move charges or spark light. It whispers only in the rarest places inside the core of stars, in the heart of radioactive decay, in the delicate transformations that keep both suns and life glowing. It is called the weak nuclear force, though its influence is anything but unimportant. Without it, the sun would never shine, the stars would never burn, and the fundamental processes that make energy usable in the universe would simply not occur. The weak force is what allows certain particles to change identity, to transform in precise, regulated ways that release energy in forms that life can harness. In fusion, in decay, in nuclear processes that feed stars for billions of years. It is the weak interaction that allows a proton to become a neutron, or vice versa, releasing a burst of possibility that becomes warmth, light, radiation memory. And yet, it operates only at unimaginably small scales. Its range is so short that it never acts across the atom as a whole, only inside the nucleus, only where the balance must tip ever so slightly to let transformation occur. If this force were to disappear, if the universe suddenly lost the quiet hand that allowed particles to change, then nothing would explode, nothing would tear itself apart. It would be more delicate than that. The changes would arrive in silence. The sun first and most intimately would begin to fade, not instantly. It would still glow, still shine for a time, but the process that fuels its heart would stop. Hydrogen could no longer fuse into helium because the first step, the gentle transformation of protons into neutrons, would fail. The chain reaction that gives the sun its life would be cut at its root. The light we feel on skin, on leaves, on windows, light that has traveled for 8 minutes from the core of our star, would begin its long goodbye. The photons already en route would still arrive. The warmth stored in oceans, in soil, in breath would linger, but the engine would have stopped, and as those final pulses of light reached Earth, they would carry with them the last moments of a fire that had burned for 5 billion years. Slowly, imperceptibly, the sun would cool. The glow would soften. Photosynthesis would begin to falter. Plants would struggle, then stop. The base of the food chain would lose its anchor. Energy, once captured from sunlight, would no longer renew. The air would cool. Winds would still. Clouds would hesitate. Weather would flatten into cold. Days would remain, but their brightness would dim. Not from distance, not from eclipse, but from the absence of change inside the sun itself. At the level of life, the transformation would be quiet. Radioactive decay, a source of internal warmth, and a subtle driver of chemical evolution, would cease. The Earth's core, heated in part by such decay, would begin to cool more rapidly. The magnetic field born of the planet's molten iron would weaken. Protection from cosmic radiation would falter. Particles from deep space would arrive unopposed, but there would be no light show, no fire. Just an invisible thinning of shields. In biology, the effects would be stranger. The potassium in our bodies, slightly radioactive, would stop emitting the quiet radiation that our ancestors' ancestors evolved with. Certain mutations would vanish, others would never occur. Evolution itself would slow, not stop, but lose one of its hidden engines. And even the technologies we use to see the past, to scan bones, to image the body, to date the age of stone and star, would go blind. The clock of carbon-14 ticking through the weak force would fall silent. History would become harder to measure. And yet beyond the scientific and the stellar, there is something more intimate in this quiet loss. Light itself is more than photons. It is warmth, direction, rhythm. The rising of the sun is the signal of time. The glowing of stars is the signal of place. Without the weak force, light would still exist for a while, but it would stop being born. And as light faded, the sense of forward motion might fade with it. Life does not need brightness to continue, but it needs difference, transition energy. Without transformation, all things would eventually cool. And though the darkness might come slowly, it would feel complete. Not because of fear, but because of absence. But tonight the weak force still breathes. Stars still change hydrogen into helium. The sun still pushes photons outward through layers of pressure, feeding light across space. The leaves still open to catch it. The eyes still narrow to greet it. Inside your body, decay still hums, not as a danger, but as a gentle legacy of a world in motion. And in that motion, rest becomes possible. The world is still warm. The air still moves. The transformation of particles still feeds the transformation of life. So as sleep begins to settle in your chest and your thoughts slow, and the weight of your limbs deepens into comfort, know this: the light you feel even in darkness was born in a fusion that still works. The force that allows stars to shine is still present. And because it is everything around you, this moment, this breath, this night, still holds its place in the unfolding story of time. There are few equations that have ever carried as much weight with so few symbols as EXMC2. a handful of letters and numbers, yet behind them lies the quiet revelation that mass and energy are not opposites, not even separate. They are one and the same, convertible, interchangeable, different forms of the same underlying essence. This insight did not arrive with drama, it arrived with clarity. It told us that the energy in a small amount of matter is immense, that the sun shines not from burning fuel in a furnace, but by turning mass into energy with every passing second, that the universe is not built of matter alone, but of relationships, becoming energy, energy becoming mass, depending only on the frame of reference and the flow of time. And in that same equation lies the framework of modern physics, the quiet machinery of stars, the hidden tension in every atomic nucleus, and the power latent in every speck of dust. But what if it were wrong? Not because the numbers failed, but because the relationship itself no longer held. What if mass could not become energy, and energy could not become mass? What if E no longer equaled mc2? The first thing to vanish would be the stars. Their warmth, their light, their very existence depend on the conversion of mass into energy. In the heart of the sun, fusion turns hydrogen into helium, and in doing so releases energy by the most elegant alchemy, shedding a small amount of mass in the process, transformed directly into photons. Without this conversion, the process halts. The pressure builds, but no light escapes. The balance between gravity and radiation disappears. The sun would shrink under its own weight, or flare into chaos, unable to manage the force it once balanced with such grace. The night sky would lose its lamps. Galaxies would become cold spirals of matter unlit. Planets formed from the remnants of starlight would never emerge. Even if they did, they would be dark, lifeless stones, warmed only by the afterglow of some primordial energy no longer renewable. On Earth, everything from nuclear power to the color of the flame would change. Decay would stall. Reactions that once released energy would become inert. The subtle difference in mass between reactants and products, the hidden source of power in every transformation, would disappear. The binding energy of atoms would lose meaning. The structure of matter might hold for a while, but its dynamics would collapse. Chemistry would feel different. Biology would slow. The metabolism that turns food into life relies on a cascade of energy transformations, each subtle, each dependent on the ability to move between forms. If energy could no longer emerge from mass, the chain would break. Cells would tire faster, muscles would slacken, thought itself would dim. Even photosynthesis, that ancient dance between light and matter, would stutter. Plants take in photons' energy and build form. If that bridge between mass and energy were broken, the exchange would stop. Growth would stall. Seasons would blur into stasis. Time would still flow, but nothing would rise. The earth would still turn, but it would carry less story. Technology, too, would unravel. Every calculation in physics, every GPS signal, every atomic clock, every particle accelerator, they all depend on relativity, on the consistency of that simple truth. E equals mc squared. Without it, predictions would fail, satellites would miscalculate, orbits would shift, our maps of space would lose accuracy, our equations would bend, then fracture. But the deeper change would be philosophical. Because what Einstein gave us was not just a formula, it was a window into the unity of things, a reassurance that the universe, no matter how chaotic, is governed by coherence. That time and space are linked. That mass is not a burden, but a reservoir. That light travels at the same speed for all observers, no matter their motion. If relativity faltered, that consistency would falter too. Time might pass at different speeds in ways we could no longer predict. Simultaneity would break. Causality would drift. The very concept of a shared now might lose meaning. And with it, the comfort of shared experience. But none of this has happened. Not yet. Tonight, the equation still holds. The sun still burns because mass still becomes energy. The warmth you feel is still the echo of that transformation traveling across space to touch your skin. The body still converts the food you eat into motion heat thought. The stars still whisper their secrets in the form of light, every beam carrying the proof that E does in fact equal MC2. And in that quiet certainty, there is peace. Because the laws of nature, even the strangest ones, still honor their own promises. They still offer consistency in a world that changes. And as your breath slows, as your eyes grow heavy, you are not drifting into the unknown. You are resting on the same bedrock that holds the stars. The numbers still add up. The equation still sings. And that song, soft as it may be, is enough to carry you gently into sleep. Every step we take, every object we hold, every time we pause without sliding forward into space, we are quietly held in place by a force so ordinary we forget it exists. Friction is not dramatic. It does not spark or crash or roar. It is the gentle resistance that allows things to grip, to stay, to rest. It gives shape to motion, brings it to a stop, lets it begin again. It holds feet on floors, tires on roads, pens in hands. It lets warmth build in touch, lets skin recognize texture, lets fire arise from the meeting of wood and stone. It is a quiet sculptor defining the relationship between surface and movement, between energy and resistance. But what if it were gone, not reduced or weakened, but removed entirely? A world without friction would not fall apart in explosion. It would slip away slowly, unstoppably, like a dream fading just before waking. Shoes would no longer grip the ground. Every step would become a slide. Walking would be a delicate act of imbalance. There would be no traction to hold against, no surface to push from. To move would be to drift. To stop would require something more than intention. Life would lose its footing literally and metaphorically. Doors would not stay closed. Hands would not hold tools. The smallest task, writing, eating, lifting, would become uncertain. Objects would slip, roll, spin. The world would lose its resistance. Fire would vanish first. Flames depend on friction to ignite. Rubbing sticks together, striking a match, sparking a wire, all require that brief resistance that heats. Without it, there is no heat, no fire, no flame. Even machines would suffer. Engines rely on friction to transfer energy, to brake, to grip. Belts would slide uselessly. Wheels would spin in place. Motion would become uncontrolled. The precision of gears and parts, once balanced by friction, would dissolve into noise. Cars, trains, planes, all would struggle to start, to stop, to steer. Technology would falter. But so would biology. The body, too, is built around friction. Muscles pull against bone. Joints need just enough resistance to guide movement. Cells grip to surfaces. Even our skin relies on microscopic friction to feel, to hold, to sense. Without it, touch would become distant. Texture would disappear. The feeling of soft, rough, warm, firm, gone. The world would become smooth in the most disorienting way. There would be no grip, no catch, no pause. Even sound might change. Instruments need friction to create vibration. A bow across strings, a reed against mouthpiece, a stick on drumhead, all rely on resistance. Music would fade, voices might soften. The way air moves through vocal cords is shaped by tiny frictions. Without them, speech would become slippery, indistinct. Language itself might feel different, not only in sound, but in meaning. Because friction also lives in metaphor, in the push and pull between ideas, between people. Without resistance, there is no challenge. Without challenge, no growth. The absence of friction in thought is the absence of learning. It is ease without depth. A world where everything glides might feel free, but it would also feel untethered. Rest would be difficult. Sleep, which depends on stillness, would lose its anchor. Beds would be too smooth. Bodies would shift. Blankets would not stay. There would be no warmth built by touch, no tension to release. And yet, in this imagined world of endless slipping, there is something that remains clear. Friction is not the enemy. It is the partner. It is what lets us begin and what lets us stop. It is the quiet reason why effort leads to rest, why pressure leads to warmth, why stillness has meaning, and tonight, friction still exists. Your body rests where it was placed. The fabric beneath you does not slide away. The pillow holds your head with gentle resistance. Your breath, soft as it is, moves through passages shaped by just enough tension to give it sound. The world stays in place, not by magic, but by contact microscopic hills and valleys, catching each other saying, "Stay, hold, rest." So as your limbs settle, as the day releases its grip, know that you are held not only by softness, but by the unseen resistance that gives form to comfort. Friction is still here, and because it is sleep, can come not sliding past, but settling in. Time is the one thing we never see, yet always feel. It touches every breath, every glance, every blink of thought. It is the quiet flow behind every change, the invisible thread that pulls moments forward. We do not question its presence, it is simply there. In the rising of the sun, in the cooling of tea, in the slow softening of memory. Time shapes beginnings and endings. It gives rhythm to life and meaning to motion. And though we measure it in hours and days, its true nature is far more elusive. Time may not be a thing at all, but a relationship, a spacing between events, a direction between cause and consequence. But what if time didn't exist? Not as an idea, not as a measurement, but as a real flowing property of the universe. What if the ticking behind reality simply stopped, not paused, but never began? A universe without time would not unfold, it would not begin or end, it would not move from one state to another. Everything that ever was and ever could be would exist, all at once. There would be no change, no sequence, no before or after. Without time, motion would have no direction. A falling object would be meaningless, because falling implies a journey through time. A spoken word would not unfold its beginning, and end would happen simultaneously, or not at all. Life would not live, growth would not grow, decay would not decay. The world would be a frozen possibility, like a painting with no observer, a melody written but never heard. Physics itself depends on time. The equations that describe motion, energy, entropy all rely on a variable we call t. Remove it, and the math collapses. Gravity needs time to pull. Light needs time to travel. Reactions need time to proceed. Information needs time to transfer. Even thought, even breath, depends on a forward drift through instants. In biology, time is not a backdrop. It is woven into our very structure. Cells divide in rhythms. Hormones rise and fall with the hours. The brain marks time with pulses, patterns, intervals. Without time, neurons would fire in chaos or not at all. There would be no learning, no memory, no sleep. Because sleep itself is a surrender to time's passage, a trust that the world will keep moving while we rest. But if there were no time, there would be no rest, because there would be no difference between waking and sleeping, no path from fatigue to recovery. Consciousness would be unanchored, not drifting, but frozen. And in that stillness, identity might vanish, not from pain or loss, but from timeless sameness. Even light depends on time. It moves through space with a velocity a distance per unit of time. Without time, light could not travel. It could not shine. A star would be a point of energy with nowhere to go. The sky would not be dark, it would be non-existent. And yet time is not always forward. In quantum physics, certain events do not care about past or future. Particles can entangle across distance, seemingly across time. The equations of relativity are symmetrical. They work forward or backward. But our experience is not. We move one way. We remember the past, not the future. We age, we heal, we learn. All of this is possible because entropy rises, because energy spreads, because time, though invisible, moves with us. A universe without time would lack this asymmetry. Nothing would be predictable. Or, perhaps, everything would be fixed, unchanging, eternal, unreachable. But tonight time still moves. The seconds may be quiet, but they are real. The warmth in your hands fades slowly into the room. Your breath rises, falls, rises again. Your thoughts begin to soften, stretch, blend. Sleep approaches not suddenly, but gently carried by the very fabric of time itself. You are not frozen. You are unfolding. The night is not a still picture. It is a current. You are floating on it moment by moment. The earth still turns. The stars still shift. The cells in your body still tick their internal clocks. And as the world spins forward, you move with it. Not rushed, not delayed, but right on time. So let it carry you. Let time hold you, not as something to race against, but as something that allows everything to be mine. Time is not the enemy. It is the breath of the universe. And tonight it breathes for you. Gravity is the quiet pull beneath every step, every drop of rain, every heartbeat that stays anchored in a chest that does not drift. It is not loud, not visible, not felt directly, but its presence defines direction. It gives weight to thought, to form, to existence itself. It is the reason the oceans stay, the reason breath rises and falls without floating away. It holds mountains to the earth, moons, to planets, planets, to stars, stars, to galaxies, galaxies in motion across the dark. It holds everything. And it does so without asking to be noticed. But what if it reversed? What if gravity, the gentle tug that keeps us grounded, turned inside out and became a push, a repulsion, not an embrace? The consequences would not be instant annihilation, but a slow undoing. At first, things would feel lighter. Steps would bounce. Bodies would move with unfamiliar ease. The ground would feel like it was loosening its grip. But soon, feet would not stay planted. Furniture would slide. Structures would stress. Trees would pull from soil. Rivers would rise against their beds. The atmosphere no longer pulled close to Earth would begin to lift. Air molecules, now free from the embrace of mass, would spread upward, thinning, cooling, escaping. Breathing would become harder, then impossible. The sky would begin to bleed into space. Oceans would peel away, not as waves, but as mist climbing upward, dispersing. The crust of the planet itself would begin to crack, not from fire or quake, but from gentle, persistent lift. The earth would fragment not violently, but inevitably, pieces drifting into the dark. But before the world unraveled, before the continents tore, we would feel it in ourselves. Our bones, our muscles, our balance, they are all calibrated to gravity. The way the heart pushes blood upward, the way ears maintain equilibrium, the way joints bear load. All of it depends on a downward pull. Reverse that and the body becomes disoriented. Blood might pool in the extremities. Vision might blur. Movement would lose rhythm. Even sleep would falter. Without weight, the body cannot settle. The pressure that tells muscles they are supported would be gone. Dreams might stretch or drift too long. The sense of lying down would become unclear. You might float within your own bed, gently pressing against ceiling or wall. But beyond biology, the deeper loss is psychological. Gravity gives more than structure. It gives orientation. It defines down. Without down, there is no center. There is no return. There is only a way. The mind used to referencing the world by position would struggle to recalibrate. Above, below, here, there all would blur. The architecture of perception would soften. Time might feel longer. Motion would become surreal. The Earth's orbit around the sun, delicately balanced between forward motion and gravitational pull, would falter. With repulsion instead of attraction, the Earth would drift away, flung outward, accelerating into deep space. The sky would darken as the sun grew smaller. Heat would vanish. Photosynthesis would stop. Life would pause, then fade. And yet this would not be loud. It would not be fire and flood. It would be stillness unglued, structure becoming motion. A slow exhale with no return. But tonight gravity still pulls. The earth still turns. The oceans still rise and fall against the shore. The air still gathers around your lungs, held gently in place. Your body still rests on the surface of the world, not pressed too hard, not flung away, but held. Beds still cradle. Homes still stand. Trees still root. Sleep still arrives, not as a fall, but as a gentle letting go. You are not drifting. You are grounded. The pressure you feel beneath your back is not a burden. It is the signature of gravity saying, I am here. I have not let go. So, as the night settles, as your breathing evens, as your muscles release their effort, you can let yourself be held. The earth has not stopped pulling. The center still calls. And because it does everything around you, this room, this body, this moment still has direction, still has peace. There is a number that has no end, no pattern, no rhythm. Yet it holds the form of everything circular in its quiet, infinite stream. It is pi, the ratio between the circumference of a circle and its diameter. From the smallest ripple on a pond to the arcs traced by planets in the sky, pi is written into the fabric of geometry of motion of waves. It is not a human invention, but a truth discovered, a key that appears wherever curves exist. And though we know only its decimal approximation, its meaning is absolute. It is a constant, unchanging, universal. But what if it weren't? What if pi were not 3.14159, but something slightly more or slightly less? What if the ratio changed, not dramatically, just subtly across the cosmos, or even across time? The change would not be loud. It would not shatter glass or burn skies, but it would echo everywhere. Every circle would distort. Every orbit would shift. The geometry of space itself, dependent on the structure of curved dimensions, would become something else. On Earth, buildings would lean not from wind or weakness, but from miscalculation. The paths of bridges, tunnels, domes, all drawn from circular mathematics, would misalign. Engineering would unravel, not from force, but from flawed foundations. Wheels would no longer roll evenly. Clocks would lose accuracy. Gyroscopes, compasses, instruments that depend on symmetry would falter. Flight paths would drift. Satellites would miss their mark. GPS systems reliant on orbital mechanics would skew. And beneath all of it, reality itself would begin to feel unfamiliar. The atom, often compared to a miniature solar system, would behave differently. The paths of electrons, already strange and probabilistic, would reshape. The harmonies of light, emitted by atoms, would shift. Spectra would alter. Color, taste, vibration, all rooted in circular patterns, would become subtly foreign. Music might sound slightly out of tune, not off-key, but off-center. Harmonies built on ratios derived from waves curved through space, would lose their resonance. The scale of sound would stretch or compress. Notes would not quite resolve. Melodies might feel unsatisfying in ways we could not name. And in the body, which is a symphony of cycles, heartbeat, breath, circadian rhythms, those misalignments would reach into sensation. Sleep might come later. Wakefulness might rise too early. The rhythms of digestion, of attention, of hormonal tides would shift. Not enough to harm, but enough to unbalance. Time, too, would feel less anchored. Our concept of time is wrapped in circular motion, the turning of Earth, the orbits of moons, the spin of atoms. If the underlying constant behind these circles changed, the measure of time would become inconsistent. Clocks might need constant recalibration. Days might stretch or shrink unpredictably. Calendars would blur. But perhaps most unsettling thought itself might feel subtly different. The mind, which organizes itself in loops of memory and reflection, relies on a certain internal symmetry. Reflection, recursion, repetition, all forms of circular reasoning in the best sense. Without true circularity, the process of returning, of remembering, of recognizing might weaken. Conversations might feel incomplete. Emotions might loop without closure. Stories might drift without ending. Meaning might stretch too long or snap too early. The circle, after all, is not just geometry. It is metaphor. It is how we understand cycles, promises, time itself. To alter pi is not only to change the curve of a wheel, it is to change the way things return. But tonight pi still holds. The circle still completes. The moon still arcs gently across the sky. The ring of a bell still carries resonance. The wheel still turns with balance. Your breath still rises, crests, and falls in a perfect rhythm, drawn from the ancient mathematics of the body. Sleep, too, comes in circles, waves of lightness and depth, of dream and waking. And because pi remains true, those circles still close. The night still curls inward, holding you gently. So let yourself rest inside that constancy. Let your body trust the roundness of the earth, the circular pull of its gravity, the softness of a world that still spins true. Pi has not changed, and because it hasn't, everything you know still fits. Symmetry is everywhere. It is not just in the mirror, or in faces, or in the wings of butterflies. It is in the laws that govern the universe, in the particles that spin and pair, in the forces that balance and oppose one another. It is hidden in the fabric of matter and the structure of space. Symmetry is not decoration, it is stability. It is the reason why matter and antimatter nearly matched, why charges cancel, why forces oppose with just enough strength to prevent collapse or explosion. It is why the equations of physics remain the same, whether you're looking left or right, forward or backward, up or down. Symmetry gives the universe a kind of grace, a coherence that allows complexity to build without breaking apart. But what if symmetry did not exist? What if the universe had never known balance? If the left never matched the right? If positive charges found no negative to cancel? If every action had no equal and opposite reaction? The result would not be chaotic in the usual sense. It would be unbalanced in a way that never rests. Forces would dominate without counterforce. Particles would accumulate with no partner to neutralize them. Structures would favor one side, one spin, one twist, and never return to center. The atom would not be what it is. The orbit of electrons depends on the symmetrical spread of charge. Without that, their motion would collapse or scatter. Molecules would be lopsided, unable to align. Bonds would become unstable. Chemistry would fail to repeat its patterns. Reactions would happen differently in one direction than another. In biology, left-right asymmetry does exist in hearts and hands and organs, but it arises from a deeper symmetry at the molecular level. Without that foundational symmetry, life could not reliably copy itself. DNA built on mirrored base pairs would not hold. Proteins which fold, based on symmetrical forces, would misfold. Function would collapse. Evolution would become a path without repetition, without inheritance. Species would flicker out after one generation, unable to stabilize. And if we looked higher into the sky, the imbalance would become overwhelming. Gravity might pull in one direction, but not be felt equally in return. The Earth's orbit might spiral without closure. Light might curve differently depending on where it came from. Galaxies might spin more in one direction than another. The night sky would lose its quiet geometry. The constellations would shift unpredictably, patterns broken before they could be named. Even time, which we think of as a flow, is shaped by symmetry. Many physical laws are time reversible. Their math does not care if time moves forward or backward. What gives time direction is a small asymmetry in entropy, a chosen imbalance. But without the underlying symmetrical laws, time might become jagged, broken, unable to progress evenly. Some moments might stretch, others collapse. Experience would be difficult to hold, memory would become distorted. Language, which relies on mirrored sounds, on syntax that balances cause and effect, might lose its structure. A sentence might begin without end. A thought might not return to itself. Emotions might become stuck, unable to resolve. Relationships might lose their mutual exchange. Giving would not meet receiving. Listening would not meet being heard. Meaning itself could fade in a universe without return. Without symmetry, rest would be elusive. Because symmetry is how the world resets. A pendulum swings equally both ways. A breath in is followed by a breath out. Sleep follows wake and then returns again. Without symmetry, rhythms would fall apart. Sleep cycles might stretch too long or snap too short. The body would not know when to rest. The mind would not know when to let go. But tonight, symmetry still holds. Your lungs fill and empty in balance. Your heart contracts and relaxes. Your limbs rest evenly on the bed. The room has shape because light reflects evenly. The world remains still because forces meet their counterparts. The stars do not fall because gravity is matched by inertia. The sky does not collapse because the dark is balanced by the presence of light. Even your thoughts, now softer, slower, return to themselves in mirrored echoes. This is the comfort of symmetry, not perfection, but return, not control, but coherence. The knowledge that the world turns and will keep turning, that the waves rise and fall, that after this night morning will come not by chance, but because balance is written into the code of everything. So rest in that. Let your body settle. Let your mind exhale. The universe is still balanced, and because it is so, are you. There is comfort in knowing that the world behaves, that there are rules beneath the chaos, that the apple falls not because it chooses to, but because gravity pulls, that the sun rises not from luck, but from the orbit of Earth, that fire warms, water flows, light travels. We build our lives on this quiet assumption that reality follows patterns, that outcomes have causes, that the same experiment done twice will yield the same result. These are not just habits of matter. They are the foundation of meaning, of learning, of survival. But what if there were no laws? Not broken laws, not laws stretched by extremes, but none at all. What if the universe never agreed on how it should behave? In such a universe, there would be no equations, no constants, no forces to define direction. The speed of light might shift moment to moment. Gravity might pull, then push, then vanish. Electrons might orbit or not, depending on nothing. The particles that make up everything would have no reason to stay what they are. A proton could become a flame, or disappear, or split into sound. Without rules, matter loses its commitment to being matter. Atoms would not bind. Chemistry would never begin. There would be no molecules, no reactions, no stability. And without that, there would be no planets, no stars, no dust, just a swirling field of unpredictability. Not even chaos, because chaos implies a pattern beneath it. This would be pure inconsistency. The absence of rules is the absence of repetition. No sunrise, no orbit, no time. No birth, because no order could guide cells into form. No thought, because thoughts need pathways and pathways need rules. Even randomness would be too structured. This would be worse than unpredictable. It would be unknowable. A universe without laws does not shimmer with freedom. It stagnates in confusion. Without gravity, there is no center. Without thermodynamics, no flow. Without electromagnetism, no cohesion. Without quantum rules, no foundation. Light might exist, but never travel. Heat might form, but never move. Distance might stretch or shrink with no reason. In such a place, experience would be meaningless. Sensation could not arise without order. A mind could not emerge without repetition. Memory could not form. Language would not exist. There would be no continuity, no narrative, no identity. You could not even say what you means, because form itself could never repeat long enough to be recognized. This is not a nightmare. It is a non-story. Not darkness, not emptiness, just absence of structure. Even time would fracture, because time is not just the ticking of moments. It is the agreement between events that something came before something else. It is built on cause and sequence. Without laws, there is no sequence. Everything happens or nothing does. A tree might burn before it grows. A mountain might rise without land. A whisper might arrive before a thought, or not at all. And yet we do not live in that world. We live in a place where the laws hold, the constants remain, the rules, though strange, are steady. The apple still falls, the flame still warms, the stars still rise. And tonight you are not drifting through unpredictability. You are resting on structure so stable that it has endured for billions of years. Your breath moves because of pressure and flow. Your body rests because of gravity and friction. Your thoughts slow because of chemistry and rhythm. You sleep not because the world forgets you, but because the rules allow rest to follow effort. Sleep, too, is a law, a pattern of turning inward, of cycles and return. The universe in all its vast complexity still agrees to be knowable. And in that agreement there is sanctuary. You are not lost in randomness. You are home in law. So let go. Let the weight of structure hold you. Let the constancy of things give you peace. The world still makes sense, and because it does so, can you. At the heart of quantum mechanics, in the quietest corner of the universe, where particles flicker and possibility takes shape, there exists a constant, so small, so fundamental, that it defines the very boundary between certainty and uncertainty, between stillness and vibration, between knowing and maybe. It is called Planck's constant, represented by the letter H. It is not a force, not a thing. It is a limit, a threshold, a whisper that tells the quantum world how to behave. It sets the scale at which the fuzziness of reality begins, the moment where particles stop acting like things and start acting like waves where energy comes in quanta, not a continuous stream, but in tiny, indivisible steps. This constant, unimaginably small, determines how sharply the world can be known. It defines the Heisenberg uncertainty principle. It sets the size of photons, the rhythm of atoms, the structure of everything too small to see. And though it lives at a scale far beyond daily life, its consequences ripple upward through chemistry, through biology, through thought. But what if Planck's constant were different? What if it were larger or smaller? Not by much, just enough to shift the threshold, just enough to change the grain of reality. If h were smaller, the boundary between classical and quantum would shrink. The world would become more precise. Particles would act more like points, less like waves. Uncertainty would reduce. The fuzziness of position, of momentum, of energy levels would tighten. Atoms would be sharper. Electrons would follow clearer paths. Structures would become more rigid, less dynamic. Chemistry would become more predictable, but less rich. Reactions might occur too cleanly, too simply. Life which thrives on the flexible imperfection of molecules might struggle to emerge. Folding, bonding, replication, all would lose subtlety. Evolution might stall. And if H were larger, the opposite would unfold. The quantum world would spill into everyday scale. Objects once stable would become blurry at the edges. Tunneling, entanglement, superposition. Those strange behaviors, usually confined to particles, would begin to affect molecules, cells, perhaps even organs. A cup might exist in slightly different positions. A nerve signal might fire in multiple directions. Memory could become probabilistic. The mind might experience moments that stretch, loop, or split. The fabric of reality would shimmer with ambiguity. Identity built on continuity might blur. Objects might not always be where they were. Time might pass unevenly, not from relativity but from interference. Even vision could become uncertain as light waves interfere more freely. Sleep itself might change. Dreams, already quantum in their unpredictability, could spill into waking. Consciousness might learn to inhabit multiple states, not metaphorically but neurologically. But deeper than all of this, Planck's constant is the scale at which energy becomes meaningful. It defines the smallest possible change. It is what makes energy come in packets, not in waves. If H were altered, the very act of change would change. Light might carry more or less energy per photon. Heat might move in different rhythms. Radiation might become more intense or more diffuse. Photosynthesis could fail. Communication signals might drift. The universe would still exist, but differently textured. Every constant defines a scale, and H defines the grain of the universe. Change it, and you change the roughness of reality. You alter what can be known, what can be predicted, what can be built. And yet tonight, H remains. The quantum world still hums within its boundaries. The atoms in your body still vibrate with familiar rhythm. The molecules in your cells still fold in ways that hold meaning. The heat in your chest still radiates in tiny steps carried by photons whose size was set at the beginning of time. There is uncertainty, yes, but it is measured. It is not chaos. It is not error. It is the gentle grain of existence. The reason your thoughts are not fixed, but free. The reason your sleep unfolds in waves. The reason light bends chemicals react, music resonates. Planck's constant still defines the quantum world, and because of that, the world still holds its texture. So let yourself rest. Let your body soften into this measured uncertainty. You do not need to control it. You are already a part of it, a being made of quanta, of rhythm, of spacing, and tonight all of it remains in tune. There is a question that slips into quiet minds more often than we admit. It arrives not with urgency, but with a peculiar stillness. What if this isn't real? Not in the sense of illusion or dream, but in the sense of construction. What if everything, light, touch, memory, time, is code? What if the universe itself is a simulation? The idea is not new, nor is it a fantasy anymore. It lives in the margins of physics, in the wild edge of philosophy, in the algorithms of theoretical computing. Some of the most respected minds in science have entertained it not because it is likely, but because it is not impossible. The reasoning is strangely simple. If it is possible to simulate consciousness, to generate an artificial reality indistinguishable from the original, and if a civilization somewhere in the future or elsewhere has the power to run such simulations, then the number of simulations would far exceed the number of base realities. In that case, statistically, the chance that we are in the original base-level reality is vanishingly small. It is not proof, it is not faith, it is a possibility, a question suspended in the dark. If we are living in a simulation, then the laws of physics are not fixed truths. They are constraints programmed to keep the illusion stable. The constants, the limits, the symmetry, the forces, they are parameters in an equation, variables in a rendering engine. Our understanding of light, gravity, entropy, and time would still be valid within the simulation, but only because they were programmed to be consistent. The real question becomes not what the laws are, but who set them, and more importantly, can they change? Because if this universe is a simulation, then nothing is fundamentally necessary. Everything is optional. The speed of light could be capped because the system needs to conserve computing power. Quantum uncertainty could be the result of limited resolution. Gravity could be an emergent property of the code's geometry. Even the passage of time might be governed not by entropy, but by frame rate. The idea is unnerving, not because it questions reality, but because it questions permanence. It means the world does not have to be this way. The bed you lie in could behave differently tomorrow. The laws of motion might be tweaked slightly for optimization. Your memories could be saved in a temporary buffer. Consciousness might be an emergent effect of code, something written in recursive logic, evolving inside a structure of feedback loops. And yet in this possibility lies something strange and even deeper wonder. Because if the universe is a simulation, it is the most stable one imaginable. The code has held for billions of years. The constants have never drifted. The stars behave. The atoms align. Planets orbit. Life arises. Consciousness dreams. The simulation, if that is what it is not sloppy. It is graceful. It is astonishing. The question of whether laws can change depends on whether the system we are in is open or closed. If we are inside a closed loop, the rules are hard-coded. But if the simulation is dynamic, adaptive, or interactive, then laws might shift not abruptly, but in response to behavior. Glitches in the system might explain the few moments of unexplainable coincidence. The impossible alignments, the feeling of déjà vu, the strange precision of mathematics which seems to describe reality more clearly than any physical object. Why is math so effective in describing the universe? Is it because the universe is written in math? Or is it because it is literally math? If the laws are optional, then perhaps some of what we call physics is simply rendering technique. Gravity as geometry, light as frequency pattern, particle mass as a variable flag. Perhaps the Planck constant is a global setting. Perhaps black holes are processing sinks. Perhaps the quantum realm is a compression technique. But even if that were true, what would change? Because whether the universe is fundamental or simulated, we still live inside it. We still feel pain. We still fall in love. We still breathe and hope and wonder. And if those experiences are rendered rather than real, they are still real to us. The simulated sunset still brings beauty. The coded voice of a loved one still calms the nerves. Meaning is not diminished by medium. The question that keeps returning, however, is about change. If this world is optional, could the code be rewritten? Could constants shift if someone with root access decided they should? Or worse, could someone forget to maintain it? Could a cosmic garbage collection delete parts of history? Could laws begin to drift as resources are reallocated? In some ways, this idea resembles the end of physical consistency. If the rules are optional, there are no rules, but even in code, there are patterns. Best practices structure. Most simulations are built on stability. Bugs are rare, systems are optimized to remain consistent for the user, and we, if we are users or NPCs or self-aware threads of recursive logic, have been granted a simulation that behaves, a place where water still boils at the same temperature, light still bends around mass, sound still follows pressure and time. Mysterious as it is still flows forward. Could it be changed? Perhaps, but it hasn't. For every moment you've ever known, the laws have stayed. That is not an accident. It is a kind of mercy, a gift, even if none of this is real in the way we think it is consistent. And consistency is what allows peace, what allows sleep. You don't need to know what lies beyond the simulation. You only need to know that tonight gravity still holds. The warmth in your bed is not imagined. The rhythm of your breath is real in every way that matters. The code, if there is one, is still working. And perhaps deep down it cares. Or perhaps it is elegant because elegance is more efficient. Regardless, it is holding. The constants remain. The patterns hold. You are not floating in chaos. You are anchored in coherence. Whether written in matter or logic in atoms or algorithms, this world still allows you to close your eyes, slow your breath, and fall gently into sleep. And that, too, is real. There's a quiet pull in the human mind that asks always at the edges what else might be out there. Not just stars beyond stars or galaxies beyond sight, but realities beyond reality. Places where the fabric of existence is stitched differently, where the rules are not the rules we know, where the universe, or something like it, hums with a different rhythm. This is the idea of the multiverse. Not just many worlds within a single cosmos, but many entire cosmoses, each with its own beginning, its own constants, its own logic, perhaps its own form of awareness. It's a concept both terrifying and tender because it suggests that the laws we live by may not be universal truths, but regional variations. And if that's true, if other universes are real, what happens to our understanding of reality? In our universe, the laws of physics appear consistent. Gravity pulls, light moves at a constant speed, particles behave according to quantum rules. Time flows in one direction. But what if in another universe these laws were different? What if time flowed sideways or curled back on itself? What if gravity repelled? What if there were 5 fundamental forces or none at all? These are not the questions of science fiction anymore. They are the whispered hypotheses of theoretical physics. The multiverse is no longer just a metaphor, it's a framework. One that may explain why our universe is the way it is, not because it had to be, but because it could be. In string theory, for example, the idea of a multiverse arises naturally. Our universe may be one of countless bubbles, each formed with different parameters during the inflationary epoch of the early cosmos. In some bubbles, the fine structure constant is weaker. In others, stronger. In some, atoms never form. In others, black holes fill the sky. The laws we hold sacred may be nothing more than local customs. Our constants may be regional dialects. The physics of our universe could be one line in a great library of existence, each page a different universe, each written in different ink. And if other universes exist with different laws, then what becomes of understanding? Can science apply across realities? Is mathematics still universal, or is it just a language that happens to describe our local structure? Well, perhaps even math breaks in some realms. Perhaps causality doesn't hold. Perhaps logic itself is elastic. These questions challenge the very tools we use to ask them, but they also open a deeper sense of awe. In imagining universes with different laws, we confront the contingency of our own. It didn't have to be this way. The values that allow stars to form planets, to orbit water, to flow cells, to divide, they are balanced on a razor's edge. Change the mass of the electron, the charge of the proton, the strength of the nuclear force, and reality dissolves. But in the multiverse view, these balances are not designed, they are selected. Not by a hand, but by survival. Only in universes where the laws support complexity can that complexity ever wonder where it came from. So, what might a universe look like where the laws are just slightly different? Where time flows in discrete chunks instead of smoothly, where space is made of loops, not straight lines, where entropy reverses and complexity unravels over time instead of growing. In such places, life might be impossible, or it might be unrecognizable. Minds might emerge in flickers, in fields, in moments, between moments, or not at all. There may be no particles, only waves, no space, only relations, no matter, only information. But what if some of these universes do support life? Life. Life with awareness, with memory, with curiosity. Would they discover physics as we have? Would their questions look like ours? Would they dream of other universes just as we do? The multiverse, if it exists, may be full of such mirrors, realities, staring into each other across the void, never touching, never crossing, but somehow echoing the same longing to understand. And perhaps the deepest mystery of all is not that other universes may have different laws, but that those laws may still give rise to something that wonders. The idea of the multiverse also humbles our place in existence. We are not the center. We may not even be rare. Our universe may be one of countless others that flicker into being, endure, and fade. If the laws can change, then the meaning of natural shifts. The laws here feel natural only because we were shaped within them. In another universe with other rules, something else entirely might feel normal, something with no matter, no time, no thought as we know it. And yet this possibility does not diminish our world. It deepens it. It means that everything we see, the light of stars, the pull of gravity, the pulse of time, is part of a rare, precious arrangement. Not perfect, but sufficient, cohesive, alive. The multiverse does not make our universe meaningless. It makes it luminous, chosen not by design perhaps, but by emergence, by the quiet logic of what can last. To better understand what it might mean for other universes to have different laws, we can look more deeply at the parameters that shape our own. The strength of gravity, the speed of light, the ratio of masses between the proton and the electron, the cosmological constant, the rate of expansion. All of these numbers are so finely tuned that even the smallest alteration could render the universe lifeless or unstructured. This phenomenon is known in physics as the fine-tuning problem. Why, out of an infinite space of possible constants, did we end up with the precise values that allow stars, chemistry, and consciousness? Many physicists and philosophers who entertain the multiverse hypothesis turn to a concept known as cosmic natural selection. In this framework, each universe is born with a random set of physical laws and constants, and only some of them are conducive to complexity. Most are stillborn silent realms where matter cannot clump, where energy cannot flow, where time may not even move. But in a small subset, conditions fall into place. Stars form, chemistry unfolds, planets orbit, life stirs. It is not that the universe was made for life, but that life can only arise in universes where the conditions support it. And what if communication between these universes were possible, not physically but informationally? Could a mind in one universe reach across to dream the contours of another? Could we ever simulate a universe with different laws within our own computers, modeling how reality would unfold if gravity repelled instead of attracted, or if time were not a dimension but a field? Already physicists run simulations with tweaked constants observing how universes evolve under slight variations. Most result in collapse, but a few survive. And in those, something begins to organize itself. Let us consider a universe where gravity is 10 times stronger than ours. Planets in such a place would be smaller, denser, more tightly held. Stars would burn hotter and faster. The lifespan of suns would shrink. Evolution, if it emerged, would race or collapse under the burden of weight. Creatures would be squat, thick-limbed, pressed close to the ground. Architecture, if it existed, would be low and heavy. Flight, if possible at all, would be rare and sacred. Now imagine the opposite, a universe where gravity is 10 times weaker. Planets would be bloated, airy, slow to form. Mountains would grow taller. Atmospheres would extend farther into space. Creatures might be light, tall, elastic. Movement would be effortless. A jump might last for minutes. Trees might rise for kilometers, but such a world might also be fragile. Without gravitational compression, fusion in stars would struggle. Light might be faint, distant. Warmth would be sparse. Life, if born, might adapt slowly or shimmer briefly before vanishing. In another variation, the electromagnetic force could be altered. A slightly stronger electromagnetic interaction might mean atoms shrink, bonds become tighter, molecules more stable but harder to form. Chemistry would be sluggish but durable. In contrast, a weaker force would lead to loose atoms, delicate molecules, volatile reactions. Fire might be easier, decay quicker, information harder to preserve. Biology would wobble between extremes. Even more exotic is the idea of universes with entirely different dimensional structures. We live in a universe with 3 dimensions of space and 1 of time. But mathematics allows for many more. String theory, for example, describes a reality with 10 or 11 dimensions, most of which are curled up or hidden. If a universe existed where more dimensions were expanded, the behavior of gravity and motion would be unrecognizable. Orbits might not close. Structures might not stabilize. Time itself could fracture into paths we cannot follow. And then there's the question of causality. In our universe, causes precede effects. This arrow of time aligns with the increase of entropy. But what if entropy decreased? What if causality reversed? In such a universe, memories might be of the future. Plans might be made after their fulfillment. The sense of identity would be strange. Perhaps a mind would feel itself unraveling backward through events, undoing choices rather than making them. Such a being might still feel coherence, but we could never communicate. Their questions would come after their answers. What all these variations reveal is the delicate interdependence of laws we often take for granted. We assume that our physics is the only way for reality to exist because it is the only one we know. But in the multiverse view, our universe is one branch of a tree with infinite limbs, each defined by a different arrangement of rules. Some are barren, some are wild, some may be more stable than ours, some may burn with colors we cannot see. And in each, if minds arise, they might ask the same questions. What are the laws here? Are they everywhere? Are we alone? And perhaps, just perhaps, the act of wondering about other universes is itself a kind of bridge, a moment where consciousness expands beyond its local constraints and touches the infinite. Maybe this curiosity is what all intelligent life eventually reaches, not just how to survive in its own world, but how to imagine the rules of others. To look at gravity and ask, must it pull? To feel time and ask, must it flow? To hear light and ask, must it move? Some scientists suggest that the multiverse isn't just a philosophical playground. It may explain the biggest puzzles in physics today. The apparent fine-tuning of constants, the weakness of gravity, the nature of dark energy. Even the fact that the universe is expanding at an accelerating rate, all of these strange facts may find their answer not in the uniqueness of our universe, but in its ordinariness among many. We are not special. We are statistically probable among the few branches of the multiverse where the math doesn't collapse. This view also reshapes the search for meaning. In a universe where the laws are fixed, we often ask, why these laws? But in a multiverse, the better question becomes, What does it mean to exist in a universe where the laws allow minds to ask such questions? It is not design, perhaps, but it is no less miraculous. The ability to wonder is not trivial. It may be the rarest product of all possible laws, not mass, not energy, not even complexity, but curiosity. The capacity to imagine not just what is, but what else might be. This also raises a deeper possibility, one that edges into metaphysics. What if not only the physical laws vary between universes, but the laws of logic themselves? In our universe, contradiction is false. One thing cannot be both true and false at the same time. But what if another universe allows for a form of truth that admits paradox? A place where reality is layered, recursive, self-referential. Our minds struggle to imagine such places because our cognition is shaped by this universe's logic. But maybe somewhere thought flows differently, and maybe that difference gives rise to forms of experience we cannot yet name. And what of universes that contain no time at all, no progression, no flow? Just a static structure. Could consciousness emerge in such a place? Could awareness exist as a shape rather than a sequence? These are not answers. These are boundaries of thought. And perhaps that's the most valuable thing the multiverse offers us. Not knowledge, but humility. Not certainty, but permission to think bigger. Even our own universe might be less stable than it seems. Quantum fluctuations could push our vacuum into a more stable state, a transition known as vacuum decay. If such an event occurred, it could rewrite the laws of physics in an instant, forming a bubble of new reality expanding at the speed of light, transforming everything it touches. It would be silent, unnoticeable, and final. A new universe born within ours, with new constants, new rules, a reset not by design, but by accident. Still, we go on. We build science on the assumption that the laws today will hold tomorrow. And so far they have. The beauty of physics lies in its consistency. The equations that describe motion, light, heat, matter, they continue to work. If this is a simulation, the code is elegant. If this is a multiverse, we drew a card that makes sense. And in either case, the comfort remains we can rest because the world holds. Let us now turn briefly to the anthropic principle, a concept that both anchors and challenges the multiverse theory. It says quite simply that the universe must be compatible with the conscious beings who observe it. In other words, we see this kind of universe because this kind of universe allows observers to exist. It's not circular logic, it's a filter. In a multiverse filled with all possible permutations of laws and constants, only some can support awareness, and we unsurprisingly find ourselves in one of them. Philosophers sometimes argue that the multiverse makes everything meaningless. If everything that can happen does happen somewhere, then why care what happens here? But this is a misunderstanding. Meaning is not diluted by possibility. It is shaped by context. You don't love someone less because others exist. You don't value a sunrise less because there are countless stars. Meaning emerges from presence, from particularity, from being here now in this thread of the tapestry. And if laws can vary, then perhaps so can beauty. Perhaps other universes have music built on different ratios, harmonies we could never comprehend, colors that arise from other forces, lives that pulse with different rhythms. Their math might be strange, their chemistry unthinkable, but their wonder, if minds exist there, would be just as fierce. Wonder is not a function of rules, it is a reaction to coherence. And every reality, however structured, offers its own kind of coherence. In that sense, the multiverse is not a threat to identity or order. It is a celebration of them, a reminder that this universe is not inevitable, but it is real, that its laws are not universal, but they are ours, that we get to know them, to test them, to be surprised by them, and to rest in them. Tonight, as sleep draws near you, do not need to understand every constant to feel their grace. You do not need to visit other realities to appreciate this one. You need only breathe. Close your eyes. Feel the weight of your body against the earth, the pull of gravity, the stillness of air. The rules still hold. the world is still here. The laws still make sense. And that across all the strange possibilities of existence is the one thing that never fails to bring peace. There's something comforting about constants. The idea that no matter what changes in our lives, no matter how unstable the world becomes, the speed of light stays the same. The charge of the electron does not drift. Planck's constant remains fixed. These numbers are the quiet background to everything we do think and feel. We don't notice them, we rarely name them, but they are always there, woven into the equations of gravity, light matter, and motion. They do not shift. They do not grow tired. They do not forget. They are, in a way, the bones of reality. But what if they aren't as fixed as we think? And yet, in recent years, a question has emerged that seems almost heretical in the cathedral of physics. What if these constants aren't constant? What if they evolve? What if the universe is not a fixed machine, but a growing organism? One that matures, adjusts, adapts. What if the numbers we've taken as eternally true are actually changing very, very slowly? There are hints, nothing conclusive, but enough to whisper. Measurements of the fine structure constant taken from light that left distant quasars billions of years ago show the faintest suggestion of drift. Not enough to shout, but enough to wonder. In a few places, it seems the laws may have been written in slightly different ink. This possibility that the very fabric of the universe might be changing its threads is as profound as it is disorienting. If constants can evolve, then the laws built on them also bend. Gravity, electromagnetism, nuclear forces all would adjust over time, and with them, the structures of stars, the behavior of matter, even the processes of life. The early universe might have burned hotter, fused elements, differently shaped atoms, under different conditions. And the future, it might cool in ways we can't model, decay in directions we can't see. Constants don't just hold physics together, they hold memory together. They hold time. But let's step back. What are constants really? They are not objects, not forces. They are values that make equations work. They define relationships. They are the links between units, the keys to conversion. The speed of light in a vacuum, the gravitational constant, Planck's constant. The elementary charge. These are not measured arbitrarily. They emerge from the way the universe behaves. But if behavior changes, why not the constants? To explore this further, let's imagine a universe where constants evolve slowly over billions of years. Perhaps the speed of light has decreased by a fraction since the Big Bang. Perhaps gravity was slightly stronger when galaxies first formed. These shifts would be subtle, undetectable in daily life. But over cosmic time, their effects would accumulate. Galaxies would form differently. Stars would live longer or shorter. Chemistry would follow new rules. And life, if it emerges, would evolve along with the laws. Some models of cosmology already allow for this. The idea of scalar fields that change value over space and time, could alter the effective strength of forces in different regions of the universe. In such a model, what we call constants are just local values of a more dynamic quantity. Our corner of the cosmos may feel stable, but elsewhere things may work differently. And over time, even our local values could drift. If this is true, then we must rethink not only the laws of physics, but the meaning of natural law itself. A law that changes is not a law in the old sense. It is a habit, a pattern, a tendency. And if the universe has tendencies instead of laws, then it begins to resemble not a clockwork, but a living system, a cosmos with memory development feedback. Evolution. What would it mean for the universe to be alive? Not in the biological sense, but in the sense that it grows, reacts, refines itself. That it is not fixed, but becoming. That it is not built, but blooming. Such a view echoes ancient philosophies, the idea of the cosmos as a living mind, a breathing entity, a vast awareness unfolding across time. Science, cautious and careful, does not speak in such terms. But as we probe deeper into the constants, we find ourselves brushing against poetry. Let us take a closer look at Planck's constant. This tiny number sets the scale for quantum effects. If it were larger, quantum fuzziness would spread upward into the macroscopic world. If it were smaller, the quantum realm would shrink away, leaving only classical mechanics. If this constant were to shift slowly over time, even by a tiny amount, it would reshape the behavior of electrons, change how atoms bond, adjust the rate of radioactive decay. Our biology would adapt silently. Our perception of matter would slowly evolve. The same goes for the gravitational constant. If gravity has changed even slightly over billions of years, the history of the cosmos must be revised. The timeline of galaxy formation, the birth and death of stars, the expansion rate of the universe, all would need new models. Some data suggest this might be the case. Observations of ancient light, cosmic microwave background, contain traces that could hint at such changes. The universe might not just be expanding, it might be learning how to expand better. And if the constants evolve, then maybe they do so not randomly but in patterns, in response to internal conditions. The same way biology adapts to pressure, perhaps the universe adjusts to complexity. A feedback loop where increasing complexity feeds into slight adjustments in the underlying constants, a process invisible from inside but shaping everything. Could life itself contribute to these changes? Could consciousness leave faint impressions on the constants the way a breeze changes the pitch of a reed? It's speculation. But it's not madness. In some theories of quantum cosmology, the observer plays a role in defining the wave function of the universe. If so, then consciousness may be more than a passenger, it may be part of the steering mechanism. And that brings us to the most radical possibility, that constants evolve not only in time, but in space. That in distant regions of the universe, the speed of light is different. That reality fractures into domains, each with slightly different rules. That the cosmos is not a monolith, but a patchwork. A quilt of realities stitched by gradients, not borders. If this is so, then meaning becomes local. The laws of physics are not global declarations, but regional dialects. And the story of the universe becomes not a single arc, but a chorus of interweaving songs, some fast, some slow, some chaotic, some deeply harmonious. Let's now go deeper, not just into physics, but into meaning. If the constants can evolve, then the very bedrock of certainty shifts beneath our feet. And yet, does that diminish their beauty, or does it enhance it? Something that changes yet persists, that adapts but remains recognizable, is not chaotic. It is alive. It is like a tree bending in the wind, not snapping. It is like a melody that modulates through keys, yet still resolves. Constants that evolve may not be unstable. They may be expressive. Consider the idea that constants evolve alongside entropy. As the universe grows more complex, as disorder increases, as time deepens, perhaps constants adapt to accommodate new forms of structure. Perhaps in the early universe, when symmetry was near perfect and matter was evenly spread, constants were simpler, tighter, narrower. As symmetry broke, as matter clumped into stars and planets and life, perhaps constants flexed as if making room. There is a concept in cosmology known as symmetry breaking. It describes how in the early moments after the Big Bang, forces that were once unified began to split apart, gravity peeling away from the strong force electromagnetism, separating from the weak. This was not destruction. It was differentiation. Like a stem cell becoming a neuron or a skin cell, the universe was not losing unity but gaining diversity. Perhaps the evolution of constants is an extension of that process, a slow unfolding of new potentials. If so, then our universe is not a finished product. It is still blooming, still iterating, still refining the conditions for awareness, coherence, and emergence. And this invites a subtle shift in how we speak about reality. We stop saying the universe is and begin saying the universe is becoming. The implications for science are vast. If constants can change, then the equations we use are not laws carved in stone, but descriptions carved in sand, accurate for now, but subject to revision. Our measurements become snapshots in a flowing current. Our models become poems, honest, beautiful, but incomplete. And the implications for the human heart, perhaps even deeper, because if the universe can evolve, then so can we. If the most fundamental parts of reality are allowed to shift, then we too can change, not in spite of the universe, but in harmony with it. Growth is not a flaw, it is the pattern. So tonight, as you lie in the quiet curve of rest, feel the constants holding you. They are ancient, yes, but perhaps not immortal. They have carried light across space for billions of years. They have shaped matter into galaxies, stars, and hands. They have cooled just enough to let atoms dance, just enough to let memory form. And yet they may still be learning how to breathe. Sleep, then, in a universe that is not fixed, but faithful. Not frozen, but unfolding. The constants still hold, and in their quiet grace, so can you. There's a kind of comfort in the idea of things having edges of matter being made, of pieces of the world being built from something solid no matter how small. Particles, we are told, are the foundation of everything. Quarks, electrons, neutrinos, the zoo of the Standard Model, each with its mass, its spin, its behavior etched in the invisible ledger of physics. We imagine these particles as tiny marbles, or points, or maybe vibrating strings. They are not ideas, they are ingredients. They make up all the stars, the stones, the cells, and the thoughts. But what if they stopped? Not disintegrated, not exploded, but simply disappeared? What if the particles that form matter suddenly ceased to exist, or perhaps more strangely ceased to remember that they exist? A universe without particles is not just empty, it is undefined. Without particles, there is no matter. Without matter, there is no form. Without form, no texture, no structure, no memory. Not even void, just the absence of difference. A stillness deeper than silence. To imagine this, we must walk carefully, slowly through what particles actually are, because they are not things exactly. They are excitations, ripples in fields that stretch across all of space. An electron is not a pebble, it is a dance, a moment of energy rising from the vacuum, behaving consistently according to certain rules. Particles are not fixed, they are events, patterns, manifestations of relationships, and that is what makes their disappearance so haunting. Because it is not the vanishing of objects, but the vanishing of possibility. When particles forget themselves, the fields go quiet, the ripples still, the rules unwrite. It is as if the canvas stops knowing how to stretch. Yet, particles are not permanent. In quantum field theory, particles pop into and out of existence constantly. Virtual particles borrow energy for a flicker and return it. Particle and anti-particle pairs annihilate. Neutrons decay. Protons perhaps will eventually dissolve over unimaginable spans of time. The universe is not made of eternal blocks, but of temporary arrangements, of music, not bricks. So, what would happen if one day this music stopped, if the particles one by one simply ceased to be? The atoms in your body would dissolve, not explode, just fade. The bonds that hold molecules would lose their anchors. The stars would dim not in collapse, but in erasure. Gravity, tied to mass, would lose its grip. Space-time itself might unravel, not torn, but forgotten. And what would remain? Not empty space, because space is defined by what is in it. Without particles, even the metric of distance loses meaning. There would be no here, no there, no between, just a kind of waiting. To understand the implications of a particle-less universe, let's look more closely at what matter really does. Matter is not simply substance, it is memory. The position of a rock, the shape of a tree, the orbit of a planet all depend on particles remembering how to behave. An electron does not choose its spin anew each second. It follows rules. The rules are not suggestions. They are habits written into the very geometry of the vacuum. When particles vanish, the memory goes too. The geometry becomes smooth, flat, silent. Take hydrogen, the simplest atom, a proton and an electron held together by the electromagnetic force. Remove the electron and you have a bare proton. Remove the proton and you have nothing. No atom, no chemistry, no water, no stars. Now scale that up. Remove all particles, and even the idea of hydrogen becomes meaningless. All of chemistry unravels. There is no periodic table, no molecular bonds, no structure. Without particles, carbon does not exist. Oxygen does not exist. Thought does not exist. You might imagine a universe made only of energy or of pure fields with no excitations. But even energy needs a carrier, and fields without excitations are indistinguishable from emptiness. Photons, the carriers of light, are particles. If photons disappear, there is no light, no warmth, no radiation. The cosmic microwave background, the oldest light in the universe, would go dark. Even time becomes unmeasurable because time as we understand it is marked by change, and change requires something to change. Yet strangely, physics already allows for the temporary disappearance of particles. In the early universe, moments after the Big Bang, there were no atoms, only a soup of energy and probability. Matter had to cool into form. And in the far future, if the universe continues expanding, particles may decay. Some models suggest that in a trillion years, protons will decay into energy. Matter will slowly dissolve. Stars will stop forming. Black holes will evaporate. The universe will become thin, silent, forgotten. But this is a slow forgetting. What if it happened all at once? What if in a moment particles simply lost their instructions? This would be deeper than a vacuum. It would be an ontological collapse. Reality would not explode. It would go quiet. Not death, not destruction, but a vanishing of context. A place where the word exist has no anchor. From a quantum perspective, particles are excitations in their respective fields. If these excitations cease, does the field itself persist? Or is it the excitation that gives the field meaning? Imagine a violin string stretched but never plucked. Is the music still there? Potential, perhaps, but potential without pattern is indistinct. Without particles, fields have no voice. Without voice, physics has no song. And yet here you are, breathing, resting, held by a body made of particles that still remember. Your hands, your chest, your breath, all composed of atoms that behave as they did yesterday and will tomorrow. The constants hold, the particles persist, the fields hum gently in the dark. Let's explore what the disappearance of particles would mean for time. Time is not a background, it's a relationship between events. In physics especially, relativity, time, and space form a single fabric space-time. But that fabric is stretched and shaped by energy and mass. Particles give that fabric context. Without particles, without the ticking of electrons in atoms, without the oscillation of fields, there would be no clocks, no pulses, no memory. Time would cease to be meaningful. It might still stretch, but it would not move, because movement requires distinction. Now consider perception. Our senses are built from interactions between particles. Photons striking the retina, molecules binding to receptors, vibrations moving through air and touching eardrums. Even dreams are built from neurotransmitters, from synapses firing via charged ions. Without particles, there is no perception, no self, no boundary between the dreamer and the dream. Identity dissolves not in death, but in non-distinction. And what of consciousness? Is it made of particles? Certainly our brains are. Our thoughts emerge from interactions between atoms, between waves of sodium and potassium, between molecules shaped by proteins, which are shaped by DNA, which is written in carbon, hydrogen, nitrogen, all particles. But the pattern of consciousness may be something deeper. If particles disappeared, would the pattern still echo somewhere? Would it imprint faintly into the vacuum? Would a universe with no matter still remember the shape of a thought? These are not testable questions. They are quiet meditations. They are the lullabies of physics, soft hypotheses not meant to solve but to hold, because the point is not that particles will disappear tomorrow. They won't. They are still here. They still sing. The world still holds. But knowing that they might fade that reality, could forget, makes this moment more precious. The feel of sheets against your skin, the warmth in your chest, the faint rhythm of breath. These are not small things. They are arrangements of particles, billions of years in the making. They are the memory of stars cooled into form. It is easy to forget how fragile matter is, that atoms are mostly empty, that particles are mostly fields, that everything solid is mostly pattern. You are not made of stuff. You are made of relationships, of arrangements, of harmony. You are the music of matter briefly played, so sleep tonight in gratitude. Not because the particles will last forever, but because for now they do. The fields remember their song. The universe has not forgotten its form. The atoms still hold their shape. The constants still hum. And in this delicate, persistent structure, you find yourself held, not by accident, not by certainty, but by the rare and quiet miracle that matter still remembers itself. We spend most of our lives moving through space without ever noticing it. We sit, we stand, we sleep, we breathe, and all of it unfolds inside a volume we take for granted. Space seems passive, an invisible backdrop for the things that truly matter: objects, energy, movement, memory. But modern physics whispers something more profound. It tells us that space is not empty. It is not still. It is not even separate from the things that move through it. It is structured, woven, alive with invisible fields, fields that shape how particles behave, how forces interact, how time flows. Fields that are always here even in a vacuum. Fields that do not wait for matter to arrive. They are the fabric, and like any fabric they can stretch or tear. According to quantum field theory, every particle we know, every electron, photon, quark, is not a discrete object flying through space, but a ripple in a field that already exists everywhere. An electron is an excitation of the electron field. A photon is a wave in the electromagnetic field. These fields aren't placed on top of space, they are space. Or, more precisely, they define how space behaves. The structure of reality is not made of things in space, but of the behavior of space itself. And if that behavior changed, if those fields collapsed or frayed, the very nature of existence would shift beneath us. These fields, as abstract as they sound, are the reason anything exists, the reason atoms have size, the reason light travels, the reason matter clumps and stars shine. They are silent, stable, persistent, until they're not. Theoretical physicists have long pondered the idea that the vacuum we live in the state of these fields may not be the most stable configuration. It may just be good enough, a local minimum, a false vacuum. That is, our reality may be balanced delicately on a plateau of field energy, not because it must be, but because it has not yet fallen to something lower. In this frightening scenario, space, as we know it, could suddenly rearrange. A fluctuation, tiny rare, could trigger a transition from the current vacuum to a lower energy vacuum, a true vacuum. The result would be a bubble of new reality expanding at the speed of light. Inside the bubble, the values of the fundamental fields would be different. Mass might not exist. Gravity might not act. Atoms wouldn't hold together. Chemistry would vanish. Everything we know would be rewritten or erased. This is not a science fiction premise. It arises naturally from our best understanding of quantum field theory and the nature of the Higgs field, the field responsible for giving particles their mass. Some calculations suggest that the current value of the Higgs field is not truly stable, but metastable, safe for now, but not forever. If that's true, then the fields that define the fabric of space are temporary, not in the sense that they vanish with time, but in the sense that they might not last forever. Reality, it seems, is not carved in stone. It's balanced on a thread. This raises a chilling question. What does it mean for space itself to fail? Not collapse like a building, not burn like a star, but simply lose its structure. What if space forgets how to behave? If the field values shift even slightly, then everything changes. The speed of light, the strength of gravity, the electromagnetic interaction, All are governed by the properties of fields. If the fields collapse, the rules collapse. And if the rules collapse, reality becomes unrecognizable. But collapse doesn't need to be dramatic. Imagine space slowly losing tension, like fabric unwinding. Fields fluctuating a little more each decade, constants drifting, light bending a little differently, gravity losing precision. Over billions of years, structures might become more diffuse, atoms looser, stars less stable, time more uncertain, a slow cosmic forgetting. Could life survive such changes? Not in its current form. Our bodies are finely tuned to the values of the fields we inhabit, the charge of the electron, the mass of the proton, the strength of the weak force. They define the chemistry of life. If those constants shifted, proteins wouldn't fold, DNA wouldn't replicate, thought wouldn't form. Even the concept of temperature could become meaningless. A different vacuum means a different physics, a different canvas, a different story. But there is also beauty in this fragility. The fact that the universe can hold together at all, that fields can remain stable across 13.8 billion years of expansion, is remarkable. The silence of the vacuum is not emptiness. It is balance. It is tension perfectly tuned. Every breath you take is proof that space still works, that the fields still hold, that the rules haven't shifted. Let's take a moment to reflect on what these invisible fields really are. They're not mystical. They're not poetic metaphors. They are the deepest machinery of the universe, described in equations so precise we've tested them to many decimal places, yet they remain invisible. We don't see them, but we see what they do. The electron field everywhere allows electrons to be. The photon field allows light to ripple. And space itself is shaped by the gravitational field, a bending of geometry in response to energy. If those fields collapsed even for an instant, causality itself might break. Events might lose order, sequences might blur, the arrow of time, which we think of as constant, might wobble. Not reverse, but blur. Things might happen without cause, a world of shimmering confusion, a nightmare, not of pain, but of patternlessness. And yet this is not something to fear. It is something to understand. The fields have held for so long that we are lulled into forgetting how precise, how miraculous their stability really is. They span galaxies, pass through planets, hold together the sun, guide light from distant stars into your eyes. They are not merely parts of physics. They are the reason the universe is capable of being experienced. Some theories imagine universes where the fields collapsed differently, where other configurations took hold. Universes with stronger gravity or more dimensions or no electromagnetism. Universes where matter never forms or where it forms but never clumps. These are not our universe. We live in the one that balances just enough where the fields allow complexity, temperature, motion, life. So, what holds them in place? Why haven't they collapsed yet? No one knows. Maybe we're lucky. Maybe there's a deeper symmetry we haven't discovered. Maybe the vacuum is truly stable. Or maybe it's just not time yet. As you lie in bed tonight, surrounded by the gentle quiet of things working as they should, you are floating in a field that has not failed. You are breathing atoms held by electromagnetic bonds, created in stars, held by gravity, moving through space, shaped by the curvature of mass, all of it regulated by fields that stretch across the entire cosmos and beyond. Collapse is possible, but stability is actual. For now, sleep in that knowledge, not in fear of what could be, but in gratitude for what is. We live in 3 dimensions of space and 1 of time. It's so fundamental to our experience that we rarely think about it. Length, width, height, and change. These are the axes on which our lives unfold. Every object, every movement, every structure from stars to skin to memory requires these dimensions to exist. But physics tells us that this familiar landscape may not be all there is. There may be more dimensions hidden, curled, unseen. And even more astonishing, those dimensions might not be permanent. They might evolve. They might collapse. To imagine a collapse of dimensions, we first have to understand what a dimension is. In its simplest sense, a dimension is a direction and axis of movement or measurement. In one dimension, you can go forward and back. In two, you can also go left and right. In three, you can move up and down. Time, too, is a kind of dimension, one we can only move through in a single direction. But theoretical physics, especially string theory, proposes that there may be additional dimensions beyond these four, dimensions too small to see, too tightly curled to touch. In string theory, the universe is composed not of point particles, but of tiny vibrating strings. And these strings require extra dimensions to vibrate in, 10 dimensions or 11 depending on the version. The reason we don't see them is because they are compactified, curled up at scales far smaller than an atom, like a sheet of paper rolled so tightly you can't tell it has any width. These extra dimensions may hold the key to unifying gravity with the other forces of nature. They may determine the masses of particles, the nature of interactions, even the shape of space itself. But what if those hidden dimensions begin to change? What if they unravel or collapse or shift in shape? The structure of reality would follow, because the geometry of these dimensions defines the physics we observe. If they collapse, it's not just space that changes, but the forces, the particles, the possibilities. And what about the dimensions? We do see the three large ones that define our world. Could they collapse too? Could the spaciousness of the cosmos compress? Could direction itself become limited? Some theories suggest that in the earliest moments after the Big Bang, all dimensions were equal, but some expanded while others remained small. It's possible that our three dimensions are large, not by design but by chance or by ancient symmetry breaking. If that balance were disturbed, perhaps the hierarchy would shift again, and space would lose its familiar shape. The collapse of dimensions wouldn't be an explosion or a disappearance. It would be a transformation of structure. Imagine a world where height slowly vanishes, where everything flattens. Atoms become planes, motion loses direction, trees stop growing up, rain has nowhere to fall. A reality pressed thinner with each moment. Or imagine the reverse, a universe where dimensions inflate, where a fourth spatial direction blooms into existence, where objects stretch into new forms, where movement gains new pathways unimagined by any creature before. Our minds are wired to think in three spatial dimensions. We cannot visualize four, but mathematics can describe it, and physics can test it. Particle accelerators probe the boundaries of these ideas. Cosmology examines the early universe for clues. We are looking for signs, subtle hints that the dimensions we take for granted are not fundamental but emergent. And if they are emergent, they can change. Why would dimensions collapse? Perhaps due to changes in energy density, or instability in the geometry of space, or a phase transition in the fields that define dimensionality. If space is a kind of fabric, then dimensions are its threads, and threads can loosen, or tangle, or break. What would it feel like to live through a dimensional collapse? Would it be violent, disorienting, or gentle? Would you wake up one day and find your world subtly changed? That turning a corner feels different, that motion is bent, that light curves oddly. Perhaps it would be subtle at first. Perhaps reality would ripple before it folds, or perhaps we would never feel it because the collapse would erase the experiencer. And what about time? Could time collapse? Could duration itself compress like space? Some theories propose that time and space are not distinct, but aspects of a single geometry spacetime. If space can bend, collapse, expand, why not time? What would it mean for a second to stretch into eternity? Or for hours to fold into a moment? Memory would flicker. Sequence would blur. Consciousness might shimmer into stillness. But perhaps the collapse of dimensions is not an end. Perhaps it is a transformation, a migration to a new structure. Like ice melting to water or water turning to vapor, perhaps space too has phases. Maybe our current dimensionality is just one phase among many. Maybe collapse is not destruction, but reformation. To understand what happens when dimensions collapse, we can look to certain models of the early universe. In the first fractions of a second after the Big Bang, the universe was likely hot and symmetrical. No preferred directions, no distinct forces. But as it cooled, symmetry broke. Some dimensions expanded, others remained small. Forces split. Time began to flow. This unfolding created the dimensional structure we now inhabit. But what if those early conditions were not a one-time event? What if symmetry can break again? What if the rules can shift once more? Some physicists propose that dimensionality itself may be dynamic changing as the universe evolves. In the distant future, the dimensional balance might shift again, not with a bang, but with a fold, not everywhere at once, but in patches. A region of space might begin to crumple. Direction might fade. Space could lose one of its axes. Movement might become constrained. A fourth spatial dimension might inflate, distorting causality, altering geometry. To us, this would not be abstract. It would be disorienting. Imagine walking forward but suddenly unable to turn left, or seeing objects flatten not from compression, but from the disappearance of dimension itself. Buildings would tilt, roads would twist, even language would falter, shaped as it is by three-dimensional thought. Our minds evolved in this stable geometry might not cope. Perception would blur, memory would lose spatial anchors. Dreams might fragment into surreal patterns, reflecting an unfolding geometry we can no longer interpret. And yet collapse may not mean destruction. Just as ice melts into water and water evaporates into steam, dimensional transitions might be phase changes. Shifts in the underlying configuration of space-time. The old rules would dissolve, but new ones would emerge. A different kind of space, a different kind of experience. Maybe not worse, just stranger. Some thinkers go further. They suggest that consciousness may, in part, arise from the dimensional structure of the universe. That our sense of self, our ability to think, to feel, to remember, may depend on the geometry of space and time. If so, then a collapse of dimensions might not just change reality. It might dissolve identity, or create new forms of it. Minds that stretch across planes, thoughts that fold into themselves, perception unbound by familiar direction. All of this is speculative, but it is grounded in our best attempts to understand the deep architecture of the cosmos. The mathematics works, the theories remain open, and the mystery of dimensionality persists. Why? 3. Why now? Why here? Tonight. As you close your eyes, remember that you are shaped by dimensions. Your breath moves through a three-dimensional body. Your thoughts drift across the arrow of time. You are nested inside a structure older than memory. And for now, that structure holds. The dimensions remain stable. The geometry of your world still makes sense. Sleep within that comfort. Float within those directions. Rest within a universe that still remembers how to stretch in 3 dimensions and flow through 1. Tomorrow may bring questions, but tonight there is shape. There is rhythm. There is rest.